afternoon to everyone. Welcome to the first conference of European Clean Energy Transition organized by the student section of Croatian Society of Chemical Engineers. My name is Laura and I will host today's conference alongside my colleague Hyrdogen. First of all, thank you for gathering in such a large number. We are located at Faculty of Chemical Engineering and Technology. Before we start, the president of the student section of Croatian Society of Chemical Engineers, Tina Zubović, will address us with a few words.
Okay, thank you, Laura. So, I wish you all a very warm welcome, and it is fallen upon me to tell you a little bit about student section. It all starts with an idea. So in 2017, a small group of students decided to go beyond the scope of their studies, and from their idea came the student section, which has grown in number every year. So in the beginning, there were 5 brave ones, and today I can proudly say that the section has 78 members. I'm certain that when you registered for the conference, you browsed our pages a bit, and if you did, you found that we are very active. Each of our projects, each new issue of Reactor of Ideas, and each school that enters our colors of engineering are created with the goal of advancing science and sharing knowledge in the general population. The popular science magazine, Reactor of Ideas, is read on 5 continents and is recognized as a particularly valuable work for promoting science, especially chemistry and chemical engineering, among young people as well as the general public. The journal is supported by the Ministry of Science and Education and is produced by students, professors, and scientists from scientific research and educational institutions throughout Croatia. Besides the Reactor of Ideas, our biggest project is Colors of Engineering, which travels around Croatia, inviting students to primary and secondary schools and using their experiments to introduce science to younger generations in a fun and accessible way. The interest of young people in our workshops is growing year by year, and I can allow myself to say that we have awakened the love of chemistry even among the youngest in our society. Our journey for Croatia has slowed down a bit this year, but that does not stop the spirit of students from continuing the workshops and finding new imaginative ways to achieve our goals. The student section was awarded Directors and Deans Awards for their work. From its beginnings to the present day, the section has had more than 30 successful projects, and it is a great pleasure to stand here on this one. The international conference that has brought such a large number of participants, especially those outside the borders of our country. I would like to give a big praise to the organizing committee who managed to hold such an event of this magnitude. You have exceeded all expectations and made me a proud member of the section. I would also like to thank all the presenters who kindly accepted the invitation, and I wish you all a successful conference. Thank you.
Tina, thank you very much. Before we start to announce our first presenter, I would like to ask the president of the organizing committee, Daniela Ivandić, to say a few words.
Hi everyone. First of all, I would like to thank you all for joining us on the first conference of European Clean Energy Transition. A lot of great lecturers will tell us about hydrogen energy in general, fuel cells, plans that promote using hydrogen energy in everyday transport, and also about frequent misconceptions about hydrogen role in a new energy order. Over the last few decades, global temperatures have risen sharply to approximately 0.7 higher than 70 years ago. Human emissions of carbon dioxide and other greenhouse gases are the primary driver of global climate change. It's widely recognized that to avoid the worst impact of climate change, the world needs to urgently reduce emissions, so we wanted to organize this conference in order to raise awareness about this topic. Our goal was to organize this event in English, so it would be available to everyone around the world. Also, we are very proud to say that we have 300 people signed up for this conference. From Croatia, Germany, Czechia, Japan, India, Israel, Netherlands, United Kingdom, Belgium, Slovenia, Italy, Serbia, Germany, Norway, and Bosnia and Herzegovina. Hydrogen energy became a really popular subject nowadays, and it involves the use of hydrogen and hydrogen-containing compounds to generate energy to be supplied to all practical uses needed with high energy efficiency, overwhelming environmental and social benefits, as well as economic competitiveness. I would like to thank the organization committee for organizing this event, and thank you all for being part of it.
Before we formally begin this conference with our first presenter, just a few instructions for the participants. We ask all the participants to have your microphone turned off during the whole conference. If you have any question for the presenters, send them in the general chat before the end of presentation. The questions will be read at the end of the presentation by the host.
The first presenter of the day is Dr. Frano Barbir. Currently, he is a professor at the Faculty of Electrical Engineering, Mechanical Engineering, and Naval Architecture in Zagreb. Dr. Barbir has been actively involved in hydrogen and fuel cell technology for more than 20 years. The topic of his lecture is frequent misconceptions about hydrogen's role in new energy order. Dr. Barbir, you may have a word.
It is my honor to be invited to this conference organized by the Student Charter of the Croatian Association for Chemical Engineers. I am a mechanical engineer by training. I got my PhD in mechanical engineering, but I have my master's in chemical engineering from the Faculty of Chemical Engineering and Technology. This conference is very timely because the European Union announced the hydrogen strategy last summer. The very same day as they announced another strategy for the integration of energy sectors. And Croatian government just last week announced decision to make a national hydrogen strategy. This is great news, of course, for all of us working in hydrogen for so many years. It seems that these days everybody's talking about hydrogen, and I'm really pleased to see so many people registered for this conference, which is also talking about hydrogen. But very often these people talking about hydrogen, they do not understand the whole concept. And many criticize hydrogen. Some of them are right, some of them are wrong, often claiming some shortcomings. And that is why I decided to make this presentation about the frequent misconceptions about the hydrogen role in a new energy order. And one correction, I'm not from University of Zagreb, I'm from University of Split in Croatia. Okay, so this is a presentation outline. I will very shortly talk about what is hydrogen, what is the new energy order, what role hydrogen could or should have in it, what are the frequent misconceptions about hydrogen, and finally, some concluding words. So hydrogen is a gas. It's a simple element, number one in the periodic table of elements. Hydrogen consists of one electron, one proton. It's a colorless, odorless, tasteless gas. Believe me, I tasted it. It's not toxic, so I survived. It's much lighter than air, about 13 times lighter than air. It's highly flammable, which makes it a fuel. All fuels are flammable. That's the definition of fuels. And it's the most abundant element in the universe. Unfortunately for us on Earth, or fortunately, depends from your point of view, it's present only in compounds, chemical compounds like water or hydrocarbons. So to get hydrogen, we have to split those compounds into primary elements. What is the new order? The new energy order is an energy system that, unlike the present energy system that we have, that is basically based on combustion of fossil fuels, mainly coal, oil, and natural gas, the new energy system that we are all streaming to will have no carbon, which means no carbon dioxide released in the atmosphere. And it will be primarily based on renewable energies like solar and wind and other available renewable energy sources. So what is the role that the hydrogen should have in such a system? First of all, hydrogen should enable large-scale, efficient renewable energy integration. It will allow distribution of energy across sectors and across regions, and sectors of energy means electricity generation, transport, energy for buildings, and energy for industry. And hydrogen will act as a buffer to increase system resilience. And at the end use, the primary applications of hydrogen will be to decarbonize the transport sector, but also to be used in the industrial sector, either as a fuel or as a feedstock for some industries. And to a smaller amount, hydrogen can also help decarbonize building heating. So what are the frequent misconceptions about hydrogen? Well, the one I found actually on an early website of this conference, somebody put a hydrogen bomb exploding as an announcement for this conference. This is a great misconception. Hydrogen, as used as a fuel, has nothing to do with the hydrogen bomb. And people often make this connection. You will laugh also later with another slide. So, and this is obviously wrong. So this is obviously misconceptions. The other misconceptions I listed here are actually mainly truths. Hydrogen is not an energy source. People criticize that, yes, hydrogen cannot replace fossil fuels because hydrogen is not an energy source, which is true. Hydrogen is mainly produced from fossil fuels, natural gas. This is also true. There is no hydrogen infrastructure. Not argue about this. There is no hope for hydrogen fuel cell vehicles because battery electric vehicles are so much better. Well, that should be discussed, and I will discuss it later. It is inefficient to produce hydrogen and then convert it back to electricity. Yes, that's true. Hydrogen is bulky, which means hydrogen storage takes a lot of space. Hydrogen does not create pollution, but its use will produce a huge amount of water. That's also true. And hydrogen is extremely dangerous. Okay, so let me now try to debunk most of these misconceptions about hydrogen. So people talking about hydrogen usually make one of these or few of these statements, and that's their reason why they don't accept hydrogen as a fuel in the future. Well, the whole misconception actually started by Jules Verne, who almost 150 years ago, in his book, Mysterious Island, he has a paragraph that says, water decomposed in its primitive elements by electricity will become a powerful and manageable force. Yes, my friends, I believe that water will one day be employed as a fuel, that hydrogen and oxygen which constitute it, used singly or together, will furnish an inexhaustible source of heat and light, of an intensity of which coal is not capable. Water will be the coal of the future. Obviously wrong, because hydrogen is not a source of energy. Hydrogen needs a source of energy to be produced. And this misconception continued later on. This is an early vision of hydrogen economy. I actually was a graduate student at University of Miami, and my professor, T. Nejat Veziroglu, who is the president of the International Association for Hydrogen Energy, he made me draw this drawing, which is conceptually wrong, because it shows that we will use all the energy sources to produce hydrogen, and then use this hydrogen to provide energy that we need in the consuming sectors. And that's obviously wrong, because we will not convert all the energy to hydrogen and then convert hydrogen to others. If we can, for example, directly produce electricity, then there is no need to produce hydrogen. And a similar misconception continued even to today. This is a vision of our society and hydrogen economy by Fuel Cells Hydrogen Joint Undertaking, which has the same kind of principle. Yes, we'll use renewable energy to produce hydrogen, and we use hydrogen in any sector where we use fossil fuels today. So this is kind of misleading, a little bit misleading, because we will not convert all energy to hydrogen, only that we need to convert to. So the next is the hydrogen is mainly produced from natural gas, which is absolutely true. Today, the industry in the world produces about 70 million tons of hydrogen, and about 50% of it is produced from natural gas. And another 45% is produced from either liquid hydrocarbons or coal. Only 4% of hydrogen today is produced by electrolysis, which is compatible with the renewable energy sources. So that is what is called today a gray hydrogen, is a hydrogen that is produced from natural gas. But this hydrogen, in this process, carbon dioxide is released in the atmosphere. So supposedly we can also remove this carbon dioxide from in this process, and this is called carbon capture and sequestration or utilization. Or we can produce hydrogen from renewable energy sources using green electricity, which means electricity produced from renewable energy sources. So for this energy transition that is ahead of us, the first option for the first hydrogen, gray hydrogen, is not an option. Blue hydrogen may be in this transition period, but I have doubts about this carbon capture and sequestration because I think that technology is far beyond or behind a hydrogen technology that has been developing for the last 30 years. And now I think this carbon capture and sequestration is not ready as for this scale that we're going to need it. So the whole transition should be based then on green hydrogen. One of the statements is there is no hydrogen infrastructure. And because of that, no one wants to buy a hydrogen fuel cell car unless there are hydrogen refueling stations around. On the other side, no one will build a hydrogen refueling station unless there is a number of cars around to be filled. So it looks like a chicken or egg problem. What came first? I will just go 120, 130 years in the past, because when the first vehicles came out that used diesel or gasoline, there was no infrastructure in place for the first automobiles. And if Mrs. that shows on this picture waited for infrastructure to be built, we will still be riding horse carriages. So yes, there is no hydrogen infrastructure, but it's only partially true. There is a hydrogen infrastructure that is being built right now. There are hydrogen refueling stations in the world, in Europe, even one in Croatia, unfortunately only for bicycles, but yes, and this is a map of hydrogen refueling stations all around Europe. There is about 182 refueling stations, and about 150 of them are publicly open for public, and in the world there is about 440 hydrogen refueling stations. So it's not true that there is no, it needs to be built, but this is just the beginning. Then we also always hear comparisons between fuel cells, electric vehicles, and the battery electric vehicles. And the conclusion is battery electric vehicles are so more efficient than a hydrogen electric vehicles that hydrogen electric vehicles have no chance. Yes, it's true. They are much more efficient, about 2, 3, maybe even 4 times more efficient electric vehicles than hydrogen. On average, about 2 to 3 times more efficient. But efficiency is not the only property that they should be compared to. And I listed here just some of them that came to my mind. Refueling time is much better for fuel cell vehicles than for the batteries. For batteries, over 1 hour. Yes, there are fast chargers, but fast chargers need completely new infrastructure. Fast chargers reduce the lifetime of the batteries. Then energy density, which means size and weight of these energy storage systems in the car. Hydrogen theoretically has 39.4 kilowatt hours per kilogram, but if the efficiency of the fuel cell is only 50%, that comes to 19.7. If we include tank, we come to 0.6 to 0.8, and if we include the fuel cell that comes needed to produce electricity, we come to 0.4 to 0.6. With today's technology, battery is about 0.1. Only the best batteries have 0.2 or higher kilowatt hours per kilogram. So people comparing, they always compare future batteries with the existing hydrogen technology. Then also there's issues on safety, both on the side of hydrogen, but also on the batteries. The batteries are not benign either. There's also performance in extreme conditions. The batteries don't work very well in extreme cold. There's also performance loss over time and durability, which applies to both fuel cell electric vehicles and the battery electric vehicles. And then there are materials constraints and recyclability issues. Not all of the materials in batteries, but to be honest, also on the fuel cell side, are not maybe in a short supply. I think the finally decision will be made based on cost, because when people buy a car, they don't buy a car because they like it or they don't like it, or I mean, that's also plays a role, but eventually it comes out how much money do you have to buy. So the cost will play a significant role. And if you compare the cost of the fuel cell and the battery vehicles, there is actually a crossing point here, because on this on the X side we have a cruising range of the vehicles, and on the other axis we have a system cost. So the fuel cell cost increases linearly with the cruising range, but the batteries increase exponentially with the cruising range, because if you need more range, you need more batteries. If you need more batteries, you need more power. If you need more power, you need more energy. More energy means more batteries, and it goes exponentially. So at one point, the electric vehicles are more expensive than the fuel cell vehicles. So for a short range, yes, batteries are better, but for a long range and heavy vehicles, the fuel cells may be better. That's actually what automotive companies think. And this chart shows one of the automotive companies made this chart maybe about 10 years ago, and showing that for a light load and the short distances, yes, and the city driving like stop and go, the battery electric vehicles are better. But for the heavy duty vehicles and the long ranges, the fuel cell electric vehicles are. Hydrogen is bulky. Yes, that's true. 1 kilogram of hydrogen stored at 200 bars takes 68 liters. At 350 bars, which is the standard for the buses and trucks, it's 43 liters. And at the 700 bars, 1 kilogram of hydrogen takes 25 liters. And if you liquefy hydrogen, it takes 14 liters. 1 kilogram of hydrogen contains the same energy as 1 gallon of gasoline, so about 3.87 liters. It's still about 4 to 6 times more bulkier than gasoline. And yes, if you look at the first vehicles that came out 50 years ago, the hydrogen was on the roof. When we started seriously working on this, the hydrogen tanks occupied the whole trunk, like shown in this vehicle here. The car manufacturers improved this by engineering, and they were able to put this big hydrogen tanks under the seat of the vehicle. And finally, the commercial vehicles like a Toyota Mirai that you can buy today, you don't see the hydrogen tanks and you don't lose any trunk space. So hydrogen is not really as bulky as it looked in the beginning. But hydrogen is the only energy storage medium that can store a huge amounts of energy for a long duration of time. Batteries are fine for a short storages, but the hydrogen is much better for large-scale seasonal storage of energy. It's also better than the pumped hydro and compressed air storage that are being used. Hydrogen end use creates water. Yes, that's true. And but the amount of water that hydrogen produces is about the same as it is produced today with the fossil fuels, because combustion of fossil fuels, as shown here, also produces water. That's actually completely irrelevant, because the amount of water released by energy conversion is negligible compared with the natural water cycles shown here. The natural water cycle is 500,000 square cubic kilometers, which is 5 to the power of 14 tons per year. And the fuel cell combustion generates only to the power of 10, so that's like 4 orders of magnitude less. So really, it will not contribute to any more water vapor in the atmosphere. And finally, the biggest misconception about hydrogen is its safety. Yes, hydrogen is extremely dangerous. And there's a scene in a Schwarzenegger movie, Terminator 3, where he takes the fuel cell out of his chest, and because it's broken, and he throws it away from the window, and the fuel cell explodes with the atomic bomb. Obviously, that's not, and he said, when ruptured, the fuel cells become unstable. But yes, this picture also often shows to show how hydrogen is dangerous, although this particular accident that happens in 1937, none of us was alive there then at that time, but it's actually, this shows how hydrogen is safe, not dangerous, because even in the case of this terrible accident, 56 people survived this accident, because you can see that the flames are going straight up, and the hydrogen flame doesn't radiate that much heat as a diesel heat. So most people who were killed in this accident, they either were killed because they jumped out of fear before this Zeppelin landed, or they were near the engine room that took a fire, and there was a diesel fuel in the engine room. This is actually an example of how hydrogen is actually safe. And also, it was filled with hydrogen, and of course, when it caught fire, hydrogen burned, but it was not hydrogen that caused the fire. The theory that is now generally accepted was that the lining of this Zeppelin was silver oxide, which caught fire after the static discharging from the atmosphere. This is another film that you can find online on the internet. And we did this when I was a graduate student at the University of Miami in 1990, I believe. So that's about 30 years ago. We had a Ford Focus, one that had a hydrogen tank that I showed before on the left side, and we had a gasoline tank. We drilled the holes in both of them, and then we ignited the fuels coming out. What happened with the hydrogen burned, but the hydrogen flame went straight up the gasoline flame and engulfed the whole vehicle. So this is another example how hydrogen is safer than gasoline, for example. But when we talk about the safety, that's why the tanks in the vehicle are like us put on the roof, like shown in this diagram here. So they are not really dangerous, because in case of any fire or explosion, the fire will go straight up and people underneath will not be harmed. But as engineers, we should actually not talk in anecdotes. We should actually seriously consider this, and that's what this graph shows. Shows several properties of hydrogen, of any fuel, and then compared for hydrogen with other fuels. And the red color means it's more dangerous than other fuels, and the green the green means it's less dangerous than other fuels. And you can see actually that there are many more greens than reds. So hydrogen is indeed at least as safe as other fuels, if handled properly, of course. And in the conclusion, I already talked about all of this. I'll just repeat. Hydrogen is not an energy source. That's true. Hydrogen is mainly produced from natural gas, yes, but in the future we plan to use hydrogen from green electricity produced by electrolysis of water. There is no hydrogen infrastructure, but we are working on it. There is no hope for electric hydrogen fuels electric cars. Batteries are not so much better, so there is a hope for hydrogen, especially for heavy-duty transport and longer ranges. It is inefficient to produce hydrogen and then convert it back to electricity. That's true, but we should do this only when it's absolutely necessary. If we can use electricity directly, we can use it. If we need to convert electricity to heat, we can do it. But only if we need to store it, we can put it in the hydrogen, or if we have to use this hydrogen for some other applications where it can help decarbonize our energy use or industry, then we will convert it to hydrogen. Hydrogen is bulky, but with engineering, it can be handled. Hydrogen does not create pollution, that's true, and will produce huge amounts of water, but it's irrelevant. Hydrogen is extremely dangerous. It's not extremely dangerous, it's dangerous as any other fuel if handled properly. Yet, because of all this, hydrogen has an important role in the new energy order. And I will repeat what I said before, and that's application of hydrogen in conjunction with renewable energy sources, enabling large-scale, efficient, renewable energy integration and distribution of energy across sectors, and act as a buffer to increase system resilience. Hydrogen will also help decarbonize the transport. So some cars will run on electricity and batteries, some will run on hydrogen. It will help decarbonize industry, either as a replacement of fuel, for example, in making steel, or as a feedstock. So green hydrogen used, for example, to make methanol or make ammonia or urea. And also it can help decarbonize building heat. And with this, I will thank you for your attention, and I'll be happy to answer questions if there are any. Thank you very much.
Thank you for your presentation. We have a question. Will we have to greatly change our existing road infrastructure to accommodate hydrogen-fueled cars?
The answer is very simple, no.
Okay, thank you for your answer.
Next in order is Professor Zoran Mandić, University Professor at the Faculty of Chemical Engineering and Technology, Department of Electrochemistry. He also works at International Association of Physical Chemistry as a speaker. His today's topic is battery and hydrogen-powered electric vehicles, their challenges and opportunities. Professor Mandić, you may have a word.
Okay, first of all, I would like to thank the organizers for inviting me at this nice event they organized, and thank you very much for organizing it, because I think that we should have more similar events in our country, and maybe even international, more international. The topic I'm going to talk today is about two very important technologies which are considered for the transition to the renewable energy sources and for the clean society. These are battery-powered vehicles and hydrogen-powered vehicles. Although in the battery-powered vehicles are also termed electric vehicles, electric cars, but this term is somehow misleading, because both technologies are in fact electrical vehicles. Hydrogen might be used also as a fuel for the internal combustion engines as well, but essentially nobody considers it now as a fuel for such engines. It's now only considered as a fuel for the fuel cells, which produces electricity. Why should we consider using electric cars these days instead of the cars based on the internal combustion engines? There are several factors for this, and first of all, these technologies are clean technologies, and they have no waste, they have no pollution. Batteries have no waste at all, while fuel cells and hydrogen as a fuel in the fuel cells has water, which is completely clean. Although we should look at it from different perspectives, because both technologies, batteries and hydrogen through the fuel cells, needs to be produced, electricity needs to be generated, battery needs to be recharged, and hydrogen needs to be produced. And if we use the energies for producing the electricity for charging the battery, and if we use fuel reforming for producing hydrogen, then we did not achieve much if the electricity is coming from the power plants based on the burning of the fossil fuels. So the electric-based vehicles are only important in the context of the renewable energy sources at all, in the transition to the clean society. Another point of consideration is that the electric cars have simple constructions comparing to the internal combustion engine. So it means that in general, we could expect in the future more affordable price comparing to the internal combustion engine cars. So it's made from the fewer parts and it's very much simple to produce. Also, we could compare the energies they need to, for example, move the car or the object from the location A to the location B. And the energies should be the same, but batteries and fuel cells are much more efficient than the burning of the fossil fuels. So the efficiency is better, so we might expect that we would even spend less energy for driving the same distance comparing the two cars. And finally, the power capabilities of the electric cars are better than the power capabilities of internal combustion engines. It doesn't mean that they might have a greater power, but the power could be, at the electric cars, could be achieved, the maximum power over the very broad range of the rotational rates, while on the other hand, you know that you have a gear in the electric cars and you need to be at the right gear to reach the maximum power you need at a certain situations on the driving the road. So as I said, there are two different technologies which are nowadays considered for the development of the electric cars. One is based on the battery and another is based on the hydrogen and fuel cells. So what is the difference, in fact, and Professor Barbir had already mentioned and compared two cars with different perspectives. So the heart of the both cars is electric motor. Electric motor, you could view the electric motor as one electromechanical actuator which converts the electrical energy coming from the battery. Just a moment. Coming from the battery and giving the rotation and transmission to the engine. So the performance of the battery car will be, and the difference in the performance of the battery and fuel cell car will be dependent on the performances of the two different electrochemical conversion devices, batteries and fuel cells. While battery material is contained inside the battery itself, fuel cells, in fact, is the electrochemical device which consists of inert electrodes at which, on the anode side, hydrogen is brought and it burns and it gives electrochemical reaction with the oxygen with the other side, producing the electricity, which drives the electric motor. Additional benefit of the electric cars, of the both electric cars, something which is called regenerative braking. So it means that all kinetic energy, which is which the car has, could be converted back to the battery when the car is braking, when the car is stopped. So this is advantage which is not easily to implement now in the internal combustion engine cars. So it's benefit which is worthwhile to use. So there are two directions nowadays for the development of the electric cars. Either people would like to push battery cars and to develop battery cars and try to make them readily available in the future, or there are many engineers and scientists and companies would like to make the hydrogen car and proceed toward the society which will be based on the hydrogen economy and so on. And it is not only the performance of the battery and the fuel cell which will determine the fate of these two cars. There are many other factors which has already mentioned by the Professor Barbir, which might influence the future and the selection of the cars which would be implemented and developed in the future. One of it's refueling option, refueling which differs between these two cars. And while for the battery car we have a refuel in such a way that we connect to the grid and then wait for the battery to charge. And unfortunately, this is a relatively slow process. And even with those fast charges we have nowadays, as you probably know from your mobile phones, even in such a case, we need to wait an hour or 2 hours for the refueling, in this case, charging to be finished. And it's not nice if you are stuck somewhere on the road and you need to wait for such a long time to finish or charging the batteries. On the other hand, the refueling of hydrogen tank in the car is much easier, and it works pretty the same as refueling of the present state gasoline batteries. There is also the infrastructure needed, as Professor Barbir talked about in the previous lecture. In this case, the infrastructure is much simpler, and it already exists for the battery cars. But however, the infrastructure hydrogen should still be developed, and it's really the questions of the question how it will develop, and will this vicious circle, chicken or the egg, as Professor Barbir said, which will determine the future of the hydrogen fuel. So, despite the huge progress both of these technologies have made during the last decade, I would say, there are still some challenges which need to be met in order to make these cars readily available and widespread around the world to use. And you could read in the newspapers and in portals that there is a big competitions between the companies about who developed better car, which one is better. You have Tesla, you have Rimac, you have BMW, and so on and so on. But they still lack good performance to be used everywhere. Let me illustrate this point with the following discussion. For example, today each car has a battery inside, and it's well-known lead-acid battery. And the reason why each car has the lead-acid battery inside for starting, ignition, and so on, it's because the lead-acid battery is excellent battery. And the time doesn't allow me now to explain why it's so excellent, but it's used now for more than 160 years, and it's works fine. So if we want to use lead-acid battery to drive the car, then let's see how far we could reach. Now, let's say if I have a car and I want to, with my car, which is the average car, go to visit, for example, Professor Barbir's lab in Split, then I would go through, I would take A1 highway and go from Zagreb to Split, which is about 400 kilometers. And let's say that for my car, the average energy needed is 1 kilowatt hour per 5 kilometers, which means that I would need 80 kilowatt hours per 400 kilometers. So it's, I would need 80 kilowatt hours per 400 kilometers, but of course, I would need a little bit a battery which has a little bit more energy than 100 kilowatt hours, because we need the reverse capacity, reserve capacity, and because the capacity is fading during the cycling of the battery. So I would need at least 120 kilowatt hours. So how much energy is contained here in the lead acid battery? Let's see, the lead acid battery is a relatively heavy battery, and the specific energy of the lead acid battery is about between 40 and 80 watt-hour per kilograms. So let's say it's 50 or 60 watt-hours per kilograms. So it means if we calculate these numbers, that for my car, which is about 1 and 1.5 tons, it's 1,500 kilograms, we would need a battery which weighs about 2,000 kilograms. So it's not good. So this battery would all the energy inside the battery would be needed to bring the itself from one point to the another. So what we could do now to develop the battery, which would be better, which could be inside the, which could be light enough to enable the good implementation and development of the electric batteries. So the question is, in fact, easy, and a lot of money are now invested in the world and on the European and the world level to develop such batteries. And the answer is easy, but theoretically is easy, but practically it's not so easy, as you will see now. Because what should we do? Because the energy inside the battery is, in fact, charge times voltage. And what we need to do is either to increase the charge contained per unit mass in the battery or increase the voltage. So there are many aspects. I don't have time to go deeper in it to be considered here for the development of the electric car. But what many labs are now doing, it's just combination of the material science and engineering and also electrochemical engineering. And if you now you probably all of you know that everybody's talking about lithium now and lithium batteries, but the lithium batteries, it's not so. It's the least worst option we now have in for the electric batteries. And why is the lithium so good? Because it satisfies many good. It has many good properties to be considered and to be the best option now. One of the properties is very negative reduction potential. It has. Indeed it's very high. It's -3 volts. And it's the lightest metal we have on Earth. It's with a specific capacity of almost 4 ampere hours per gram. Even more, when we multiply these two numbers, then we could reach the specific energy of watt hour per gram, which is higher than 11 watt hour per grams. So the lithium battery is now the options which is on the edge of the good battery for the implementation in the electric cars, and it would be very, very good. However, it has some problems. The problem is that we are not able to make the lithium battery as a rechargeable battery, because it's not because of the electrochemical reaction, because it's relatively fast. We could have a lithium anode inside the battery, but during the repetitive cycling of discharging and charging the lithium anode, what happens is that the so-called dendrites are formed, and because of the battery should be a compact battery, it's very dangerous. It's not safe enough, and safety is very important. And the problem is that these dendrites might cause a fire, and because they can achieve a short circuit inside the battery. Another point of consideration is that the lithium metal is usually covered with a layer which is called solid electrolyte interface, which is in fact a gift of nature. Without this layer, we wouldn't be able to have a battery, lithium battery now. But the problem is that the formation of this layer is exothermic, and it might lead to increase the temperature. And since the melting point of the lithium is relatively low at 180 degrees of centigrade, it might happen that this increase of the temperature would melt lithium, which would then produce more heat. Then it would increase the temperature even more, and that's what we call we get something which is called thermal runaway, which is very, very dangerous in situations like when you have mobiles and you drive the car based on lithium batteries. And to overcome this problem, now we have technology which is called lithium ion batteries, which consists of two electrodes, not metallic lithium, but it's the electrode which is able to intercalate lithium inside its structure, and it's formed on both sides. And this kind of the battery, it's when you view it from the outside, the charging and discharging cycles are just look like moving the lithium from anode to the cathode during the discharge, and vice versa when moving the lithium from cathode to the anode while charging. And this technology is now operative, and it's now okay, which enabled us to make recyclable battery. This is the only kind of lithium battery for now which is recyclable. And for this does not look complicated, but for this technology, three professors obtained the Nobel Prize for Chemistry in 2019. However, this technology now is still not good enough. Why? There are several options now for the anode and for the cathode materials which could be used to construct the lithium-ion battery. And all of them have some advantages and disadvantages, and this is the one figure taken from the literature, which gives the relationship between capacity and potential of the cathode and the anode. And we could construct many different lithium-ion batteries, and many manufacturers construct different lithium-ion batteries depending on the materials they want to use as an anode and the cathode. But the problem is that the increase, in fact, we witnessed the increase of the specific energy of the batteries over the years. But this increase of the specific energy of the batteries over the years are incremental increase. So in last 30 years, what we can see that we improved the battery specific energy by only 100 watt-hour per kilogram. Now the practical specific energy of the lithium-ion batteries is about 200-250 watt-hour per kilogram, which is still not satisfactory for the widespread use of lithium-ion batteries. And from the first electric car, which was driven in 1893, we need electric car today with the battery of the specific energy. This is the target to reach 400 watt-hour per kilogram today. And now the practical specific energy is about 250. So we are still not in the good position to make battery cars good. So what should we do, and what are the directions of the development? How we could reach this target of 400 watt hours per kilogram? Obviously, we are not satisfied with such incremental approach for developing of lithium-ion batteries. So we must shift our thinking toward new battery technologies. These new battery technologies could be lithium battery technologies, but not lithium-ion battery technologies, or could be something which is beyond lithium batteries. So just because of the shortage of time, I will just briefly go over this. So from what new technologies, we consider lithium technologies, could be investigated and could be developed to reach the target. So we have different chemistries here, which could be combined with the lithium to produce high specific energy. For example, we have lithium chlor or lithium sulfur and lithium oxygen and lithium fluoride. But for now, and all of them theoretically achieve very, very, very high specific energies, which could be good enough even if we only a fraction of it could be used and could be extracted in practical terms. These technologies might provide a solution for our future and for our cars. And among these technologies, there are two technologies which are actively investigated and developed. One is the lithium sulfur, and another is lithium oxygen batteries. And lithium sulfur is close to the commercialization. I'm not quite sure about the specific energy they achieved, practical specific energy, because theoretical specific energy is relatively high, more than 2,500 watt hour per kilogram. But essentially, this is something which will gradually happen over time, and probably the lithium-ion batteries will be replaced by another lithium technologies. There is also here for comparison a fuel cell, hydrogen oxygen fuel cell, and with the theoretical specific energy which is taken as a average value from different sources, and it's more than 3,500 watt hour per kilograms. So it's something which provides very high energy comparing, for example, to lithium ion now, which is theoretical 420 watt hour per kilogram. Another options for the development and then another direction for the development of the lithium batteries is not lithium batteries, but batteries is something to this direction to remove the lithium completely from the battery and to rely on different metals which have some advantages and some disadvantages, and it's the directions which might give us a solution for the future. On the other hand, I just mentioned the high energy of the fuel cells. The hydrogen has very, very high energy density comparing to the other fuels. It's because it's light and it has 40,000 watt hours per kilogram. Of course, when we construct it with the fuel cell inside, then it would go much lower to reach the value I mentioned in the previous slide, about 3,000. But the main difference between fuel cell, which will determine the performance of the electric car comparing to the battery car, is because in this electrochemical device, the electrodes are inert, and electrodes which react, which provide electrons for the fuel, in this case hydrogen and oxygen, exchange on the inert electrode. So the main problem of this fuel cells now is the inherent electrochemical kinetics of these reactions, and they are very slow. The problem which is now faced with us is that we need to increase the rate of the electrochemical reactions, and this is the main topic of the development of the fuel cell. So in comparing to the batteries, what we do with the fuel cells is that we in fact test the reactions by recording voltage versus current of the fuel cells. And what we could see from this curve here, although this is the results from the laboratory fuel cells, and these many engineering fuel cells, engineered fuel cells might achieve a better results than shown here. The main problem here is that what you see, that this current voltage curve of the fuel cell is going rapidly down. So there are two things to be considered here. One is the problem of the power, and one is the problem of the energy. So we lose a lot of energy. Energy efficiency of the fuel cells is much lower than energy efficiency of the battery. It's one point of the consideration. And another point of the consideration is that due to very slow electrochemical reactions, we unfortunately are not able to reach high powers in the car. So the fuel cells and hydrogen obviously have a lot of energy, and it would be probably much better to have a hydrogen car going from the Zagreb to Split. But for driving inside the city, battery car might prove more valuable and better options for the time being here. So if we want to use a hydrogen car, obviously we need something to boost the power of the car, and which might be another device. And I would just mention that, for example, this is well-known Ragon plot, which gives the relationship between specific energy and specific power. And for we see on the one side of this plot, we have a fuel cells with high energy and but lower power, and on the other side of the plot, we have capacitors with high power and less energy. So obviously, if we want to use fuel cells, we might think of combining it with something like, let's say, for example, supercapacitor, which could give us a power, and supercapacitors which could be used inside the car for boosting the power, is in fact also electrochemical devices. And comparing to battery, it consists of two electrodes and they store the energy by separating the charge on the two electrodes. And because of the mechanism of storing the energy, they are way different from the batteries, and in a way that they could provide a much higher power, because there is no electrochemical kinetics to be considered here, and they could provide very high power comparing to batteries and comparing to hydrogen. And also have, but they have lower energy, and they could be used also for regenerative braking situation in the battery cars. Just to conclude, there are many points which I tackled in this lecture, but I would just say that no options, no electric cars today completely meets the requirements of the clean society, and hopefully they will be improved in the near future. And the directions which the technology will go, battery or hydrogen car, it will depend on the many factors, including not only the electrochemical technology, but also from the fueling and refueling and the infrastructure at all. And at the end, I would like to thank you for your attention and hope I could answer some of your questions.
Thank you for your presentation. We have 3 questions for you. First one is, so when we talk about hydrogen-driven vehicles, what are pros and cons for vehicles driven by hydrogen internal combustion engine versus vehicles driven by hydrogen via fuel cells? So comparison is between 2 different hydrogen fuel technologies, not with traditional batteries or fossil fuels.
If I understood the question correctly, you want to compare the car run on the hydrogen as burning in the cylinder, and the electric car run on the hydrogen through the fuel cell. Am I right?
Yes.
Okay.
I may answer that question if you want.
Yes, of course you can, but I will also add something.
Yeah, go. Go ahead.
Yes, please.
Hydrogen fuel, first of all, I didn't mention hydrogen internal combustion engine, so that was wrong in the question. You misunderstood my question, my presentation. But a fuel cell car is about twice as efficient as internal combustion engine using hydrogen. So electrochemical energy conversion is more efficient because it's not limited by Carnot efficiency. So internal combustion engines using hydrogen or gasoline, doesn't matter. They have maximum efficiency at about 40%, let's say, theoretical. But that's at the full power. At the partial load, and most of the time you drive your car at the partial load. You never drive your car with a gas pedal to the bottom. So at the partial load, the fuel cell is more efficient than at the full load, as Professor Mandić has shown also. So the efficiency of a fuel cell at the average is about more than 2 times more efficient than internal combustion engine. So nobody's talking about internal combustion engines anymore using hydrogen. So we are only comparing a fuel cell electric car with a battery electric car. That's what I was doing, and that's what Professor Mandić was doing. Okay?
Yes, thank you very much. That's something which would I also say there.
Okay. The second one is, if battery catches fire, how to extinguish it?
Hopefully it won't happen if we make the batteries which are safe enough. It will be beyond the lithium batteries, but conventional distinguishers without the presence of water, if we talking about the lithium batteries, would be satisfactory. For example, CO2 or and other distinguishers would be okay, but no water inside.
Okay. Thank you. And the last one, what are problems of using magnesium or aluminium anodes in batteries?
What are the problems? But they are actively considered, both of them, as materials for the active materials for the batteries. Both magnesium and aluminium, and also sodium and potassium even, and calcium. And they have one very good advantage over the lithium batteries. Their advantage is because we could construct the anode from the metallic magnesium and metallic aluminium, which is not possible with the lithium. I mean, it is possible with the lithium to make the metallic lithium electrode, but it's not good from the recharging point of view. And that's why we have now lithium-ion batteries. But with magnesium or aluminium, or even with calcium, we can construct a metallic electrode, which provides us with much higher energy than if we make the intercalation electrode such is in lithium-ion batteries.
Thank you for your answers.
Our next speaker is Mrs. Sabine Skiker. She has been involved in the hydrogen transport sector since 2013, and from 2017 she holds the position of EU Policy Manager at Hydrogen Europe. For today's talk is on hydrogen in transportation as segment of land transportation sector and low obstacles in hydrogen implementation in transport and in general. Mrs. Skiker, you may have a word.
Thank you very much for the kind introduction. It's a pleasure for me to be with you today. So much appreciated. It's my first event with a Croatian audience. So I was actually also thrilled to see on the agenda actually the member of our Croatian Hydrogen Association, so Mr. Barbir and Mr. Pivak. Unfortunately, we never had a chance to meet, I'm afraid. But yeah, I hope this will change in the future. So I'm not sure you will find your logo super quickly here, but the logo from the Croatian Hydrogen Association should be in there, along with some over 200 members that we have currently within Hydrogen Europe. So we are based in Brussels, and we are representing, promoting hydrogen technologies towards EU decision makers. So well, we are in daily contact with the Commission, with a member of the European Parliament, and also with the stakeholders in the Council, sitting in the Council. So we have nearly 190 something company members and around 20 something association members. And here, as I was saying, I mean, it's also very important to make sure that we have the national dimension with we have the French, the German, the Portuguese, the Spanish, and the Croatian Hydrogen Association. And I'll do a mini advertising moment to actually tell you guys from the Croatian Hydrogen Association that we're organizing a workshop especially only for national associations on the 9th of March. So if you haven't received the information from my colleague Bori, feel free to get in touch. The idea is actually to see how we can further support you and how we can make this a win-win collaboration. Now, on the who we are parts, yeah, by the way, I forgot to say that my presentation will give you an overview of hydrogen strategies at European level, national levels, and then we will obviously dive deep into the mobility topic. And here I'd like to give you an overview of the upcoming pieces of legislation coming up and how we need a very integrated approach in tackling them all. But now this slide is just to tell you that we are part of a public-private partnership. So it's quite unique for such a European association, because not only we are a lobbying association, but we are also the body, one of the bodies of the fuel cells and hydrogen joint undertaking. I don't know how much, how familiar you are with that, but it's well, it's a public-private partnership with funding links to it, as you can see in energy, transport, and cross-cutting sector. And so far, I'm sure it's even more at this stage project. So over 200 projects have been supported, and of which nearly 400 million in the transport sector. So that would be big demonstration project, for example, but also looking into how can we improve fuel cells durability. Yeah, I mean, it goes from very low TRL level, technological readiness level, to pre-commercialization level. Now, so this is how it's made for the moment. That's, I mean, I will keep it short, but basically in the transport sector, we will be focusing in road heavy duty, maritime, aviation, and rail, and building blocks. So building blocks is pretty much the focus is pretty much on fuel cell systems and hydrogen tanks. And here, that's for the next partnership. So that will be the Clean Hydrogen for Europe partnership, which will kickstart this year at some points. Negotiations are ongoing. And here we will have also a bunch of funding to support the uptake and the innovation parts of our technologies. Just wanted to give you an example, and yeah, I'm afraid I had no chance to listen to previous speakers, just the previous one. So hopefully I'm not repeating something you already mentioned. But here, this was to give you the example of the Port of Rotterdam, which is also one of our members, that has a very strong plan to make Rotterdam Port basically a hydrogen port. So that's a keyword, hydrogen ecosystem. And here, if you're looking, I mean, we're talking about hydrogen imports as well, because we don't think that we will be able to sustain all of Europe with hydrogen produced in Europe only. Happy to discuss about that point later. Here, offshore wind as one way to get large-scale electricity to be converted into hydrogen and used for different purposes. So used into the transport sector, obviously, but also used for heating purposes, and even more important in a port area is the use in the heavy industry sector, what we call what the Commission calls the hard to abate sector, and that's pretty much the refinery sector, the steel sector, which, as you probably might already know, today use fossil fuels hydrogen. So that's one example. Okay, now I have to tell you about our D-Day, which was the 8th of July of last year. So that was really the first time in history that the European Commission came up with a hydrogen strategy. So it's really, so that's a way to prove, to show that the Commission is embracing the potential that hydrogen can offer. And so that was this communication laid, well, very much one big target, which is the renewable hydrogen production. So as you can see on the left here, of 6 gigawatt by 24 and 40 gigawatt by 2030. And we're talking about 1 million ton hydrogen by 24 and 10 million by 2030. Obviously, if we exceed this target, it would be even better, thinking that today 90 million ton of hydrogen of fossil-based hydrogen are being used today. On the same day, the energy system integration communication was published, which was also very important because it's the communication that says sectoral integration is key. So we must combine electricity and gas and hydrogen, basically segments together, and we cannot go in silos. I mean, silos thinking is doesn't work anymore. I can tell you, it took a lot of time to reach this type of political agreement, and that was excellent to have this communication published in July. This was also the launch of the European Clean Hydrogen Alliance, which is basically the political tool that has been set to support the implementation of the hydrogen strategy. And I don't know about all Croatian members there, but I know that, for example, the city of Zagreb, the municipality of Zagreb is represented there. As I was telling you, hydrogen momentum at European level means Ursula von der Leyen saying that next generation EU will invest or should invest in hydrogen, hydrogen being flagged as one of the key pillars for a green or sustainable industry resilience plan. And I saw that later on in the agenda you have something about funding, so I will not dive deep into that, but basically there should be funding for hydrogen. Well, there is funding for hydrogen in the different funding mechanisms, but yeah, you will have a lecture on that later on. From Vice President Timmermans, I can just say that he said several times that hydrogen rocks. Always nice to hear. Now, if we go to the transport level, This is a lady here, is a commissioner for transport, Adina Valean, and she attended one event, which was a launch of a study that I will mention shortly later on. And it was also the day where a coalition statement was signed by the whole value chain, meaning by the supply and the demand, like by the trucks operators, but also hydrogen fuel cell fuel cell suppliers, hydrogen providers, OEMs, etc. And here, this statement said that this coalition, these partners foresee that up to 100,000 hydrogen powered trucks and 1,500 stations will be displayed or deployed by 2030. Commissioner Valean was really thrilled, and you can read by yourself what she said about this. She was applauding the statement, the coalition statement. One word about hydrogen strategies, just to tell you that, as you probably already know, this is not a European story. This is a global story. And we have also, when it comes to European industrial leadership, obviously looking into what's happening in Asia will play a tremendous role. And that's also why the Commission is putting together, has put together plans, and also there is a lot of expectation from the hydrogen sector, because there, if you want me to be, if I can allow myself to be not very political, we haven't lost the technological battle at this stage. So therefore, we're still leader in electrolyzer production, for example. We must do everything possible to keep that leadership. And don't get me started with the batteries leadership. On the national hydrogen strategies, this is just to give you a flavor of hydrogen strategies that have been adopted. It's not a Western Europe story, it's a European story. And here, I think that we should put Croatia in yellow as well, as I understood that the Croatian Hydrogen Association is working on developing a national strategy, a hydrogen national strategy for Croatia as well. When you look on the right-hand side, we are not talking millions, a few millions here, we are talking billions of investment. If you just take France and Germany together, it's a 16 billion investments that are being considered. And some, of course, here, in some instance, this will be, well, the funding will be spent in the first years, like in the next years, like it would be in the recovery as part of the resilience and recovery plans. Sometimes up to 2030. When it comes to mobility, as you can see on this slide, we see some stakeholders or some member state coming up with robust plan, some others being a little bit more cautious, I would say. But if you look, and also we have added some regional strategies, because that's also from a regional perspective that you're closer to the industry, closer to the market, where you may have strategies which are more down to earth and actually more proactive or more ambitious than what you would have at a national level. So if you look into, I think we didn't even put Germany there, because the national strategy is not super ambitious. But if you look at, like the plan in Germany was to have 100 stations by 2020. And 400 by, I forgot the date, but here if you look at the North Rhine-Westphalia plan, it's 200 stations or like by 2030, but in a region only. So it shows like the ambition level. Interestingly, in Poland, there is quite a high target when it comes to buses. And of course, this is also linked to the fact that there is one large bus OEM there. I mean, Solaris is a Polish company, Polish bus company. And then it's also looking into the national markets and how national players can contribute. Well, you had your lecture already about battery and hydrogen options. Here, I would just like to agree with what the professor before me just said. indeed, if you are in a city, yeah, you go for your battery electric car. You don't need a hydrogen car if it's just for your daily usage, driving a few kilometers. If you are a taxi driver, if you're a carpooling fleet, it might actually make much more sense to have the operational flexibility offered by a hydrogen-powered vehicle. So that's for the light duty segments. And then on the heavy duty segments, I mean, obviously the higher payload you want, the payload you need, the higher energy density you need, well, the higher energy, sorry, you need, then hydrogen would make more sense. And that would be for also like 24-hour operation and harsh climate conditions. Think, for example, at an airport where you have to be yeah, operational 24/7, and where even if temperatures are really like hell, or in winter. I also just wanted to make the point, of course, FCVs are less energy efficient than BEVs. That's, I mean, no brainer. We all agree about that, and that's actually something that is brought to the table by yeah, battery electric, but people that would just favor electrification at no cost, and that would be, for me, a bit stubborn on the electrification pathway. We're saying that you need not only to look at the vehicle efficiency, but at the whole energy system efficiency. And there we start having other type of yeah, discussion and other type of considerations. Yeah, I mean, as you can see, those are the 4 segments, well, 5 segments we're looking at. I mean, maritime and aviation, we are talking more about hydrogen-made fuels at this stage. Trains, you already have trains running. I think that in something like, there are plans in something like 5-6 European countries at this stage, on top of the German trials. Trucks and bus and coaches as well. When it comes to buses, there's some like 200 something urban buses already powered by hydrogen, and plans for many more. Here, I wanted to give you a glimpse of the political framework, and especially the sustainable and smart mobility strategy. So this was communication from the Commission, laying the priorities in the mobility sector for the next 10 years. And ahead of the publication of this strategy, we released a position paper. So I would actually encourage you to read it if you want to know more. The link is actually in the, I mean, if you click on the slide, you will get directly there. And here we really favored, or what we want to strengthen is holistic approach to make sure that we are looking into yeah, I just see a few stuff on the chats. I'll tackle them at the end of the presentation. I think like the previous speaker, probably the easiest way. Yeah, so holistic approach, and here I just want to flag 2 examples. This is a Scandinavian Mediterranean corridor. So it's one of the 13 trans-European transport networks. So one of the 13 very large transport networks across the EU. And here we are looking into what would it mean if we convert half of the fleet to hydrogen powered. And so we would be talking about nearly 40,000 vehicles that would need yeah, 218 stations. And that just to give, and that would need because that's very important, a large amount of renewable hydrogen a year. And obviously the CO2 emission saving is, I mean, that one is obvious. But that's quite interesting to see the level, what dimension we're talking about here. And here, what's also, what you cannot see on this slide, but is that we are also working on the fact that we need to look into our energy networks, and that's called the TNE. You might be familiar with that already. The TNE and the TNT network. So make sure that we make a link and we make the right synergies between what we will soon hopefully see hydrogen pipelines and where you put your hydrogen refueling stations, right? So in terms of TCOs, it will, I mean, it's a no-brainer. Ports we're also working more and more, and that's probably of interest for you in Croatia, looking at ports as hydrogen hubs. So that's the example I gave you with the port of Rotterdam, but obviously this can be also, yeah, I mean, it's not just in the northwest of, in the North Sea that this technology would make sense. So that was actually when the strategy was unveiled, when the Commission strategy was unveiled in December, on the 9th of December. As I said, focus number one is on sustainability. Second is smart. So that's like artificial intelligence and how we can get to this autonomous driving, etc. And obviously they added a resilient mobility part, which was not there, which was not planned if we wouldn't have had COVID-19 to face. When it comes to the targets, I mean, you have here a summary. I think what you need to keep in mind is this 30 million zero emission car by 2030. So that's a target, 80,000 zero emission lorries by 2030. And it's 1 million charging points when it comes to battery electric cars, and 3 million by 2030. For HRSs, for hydrogen refueling station, it's 500 by 25 and 1,000 by 2030. However, we think that this is not very, I mean, not very ambitious, but it's still the first time that the Commission put an official document with a number of, well, with targets for the number of hydrogen refueling stations. Other elements that you can see here, obviously the focus on multimodality, if you can use trains or if you can use inland waterways instead of roads, this shall be done. And also the focus on climate neutral cities, I mean, and having urban areas, I mean, as a focus on urban areas to make sure that they become, well, zero emission or carbon neutral, if you like. Also, the role of the Clean Hydrogen Alliance has been mentioned, as well as Clean Hydrogen for Europe partnership that I was mentioning to you earlier in our presentation. Okay, now what matters really, and what we saw to some extent is a strategy, is this holistic approach. I mean, it doesn't make any sense to make sure that you have the cleanest vehicle possible. I mean, that's OEMs are forced to come up with zero emission vehicles if there is no infrastructure there. So that's just, yeah, it just sounds very logical, but then it means you must make sure that the legislation is going hand in hand. At the same time, it also doesn't make a lot of sense to have those vehicles if they are absolutely not affordable, and if there is no incentives or no supports to get those vehicles in the hands of customers in a near future. On our side of things, it's also the question of the fuel, to make sure that we have clean hydrogen supply, and by clean I mean low carbon and renewable hydrogen. So low carbon being hydrogen produced from steam methane reforming with CCS or CCU, and renewable hydrogen. I mean, this one I think is clear to everyone. Of course, all of this is, I mean, all of this must happen at the same time, plus the funding instruments must be adapted. So we are, for example, working heavily on adapting, on asking the Commission to adapt state aid rules, as well as looking into what the different plans. We are actually screening now what comes up from the member states in terms of recovery plans. Yeah, because that will be also, well, basically where the money is. Exactly. So here, if you take basically this slide and you put pieces of legislation corresponding to it, this is a bit scary, but this is actually what we will have to handle. most of it in 2021. And by what I'm saying to handle, we have the Fit for 55 package coming up in Q2 2021, and also another package coming up in Q3. On the vehicle side is the CO2 emission performance standard regulation for passenger car and light commercial vehicles. So that will be like number one coming up, and it was political that the Commission actually advanced the review of this regulation. It was not supposed to happen, I think it was supposed to happen in 2 years' time, but they pushed it to 2021. Then we have also there is also a point about retrofitting, to be looking into the benefit of retrofitting. It's not a piece of legislation per se. I mean, it will not be a regulation or communication or anything, but it was interesting to see that wording in the Sustainable and Smart Mobility Strategy, and we'll be digging in to get an understanding into what it means, because it could be short, like it could be a quick win. Because we need to look at everything which is possible to support the decarbonization of the transport sector. You might have this figure in mind, but transport represents something like 25% of the CO2 emission in the EU. And in order to achieve the carbon neutrality goals of 2050, we must cut the emission by 90%. So yeah, quite some work to do. On the infrastructure side, well, I could go on and on with the detail, but here maybe the other one is the Clean Vehicle Directive. So that's a regulation, that's a directive which has already been revised, but that entered into force in 2021. And here it's public procurement. It's actually pushing member states to purchase clean vehicles. So, and clean meaning gas, gas, hydrogen, battery, to cut it short, and retrofitted vehicles can also fit actually in this definition of clean. So that's for all type of vehicles, except in the bus segment, where the directive specifies that 50% of the target must be met with zero emission at the tailpipe, so BEV or hydrogen powered buses. So 50% of the target must be met by zero emission buses. When on the infrastructure side, the one that I would really like to flag is the Alternative Fuel Infrastructure Directive. Well, obviously this is, well, I see it's 20, it should be 21. It's actually all of this should be 21. That's a directive which is looking into number of stations, number of charging point stations, also gas stations, CNG or LNG, that must be put in each member state. We're in the middle of this right now. It's very exciting. On the vehicle demand side, there is will be also the review of the Energy Taxation Directive, taxonomy, the Eurovignette, which is also now at the last stage. Hopefully, it's at the last stage in the Council. Hopefully, there will be a decision there. It's like applying the polluter payer principle there. On the clean hydrogen supply, the one which is like the most important, obviously, is the Renewable Energy Directive review. So there we will be looking into the percentage of low renewable fuel of non-biological origin. And so that includes hydrogen and hydrogen-made fuels. And which percentage do fuel producer, which percentage do they have to have in their fuel mix? So for the moment, what you can keep in mind is that it's 14%, but it's very low, and it's actually already been achieved by nearly everyone. So we will also there lobby to have higher targets, and maybe to have a sub-target for dedicated sectors, like in the transport sector. Yes, that's all I wanted to say about this slide. Obviously, we could dig also into the ETS. I mean, there are so many things to be said, but I want to make sure I keep that we have enough time for question afterwards. So I wanted to give you to say a word about existing vehicle fleets, because that's also a topic that we're started to dig on. There is no EU legislation right now, which is tackling existing vehicles. It's all about the new vehicles and new registrations. But yeah, as you can see here, the fleets, the average fleets are older than 10 years old. I mean, it's from 11 years old to 13 years old when it comes to truck. We are talking here millions of vehicles which are on European roads, and that will not be tackled by the legislation. So what we have been saying is that what do we do? I mean, that we should look into the potential that carbon neutral hydrogen made fuels could play in this respect. So to have a closer look at the use of well, e-fuels is probably the word you would have heard, or synthetic fuels in the road transport sector, along with a use which is well acknowledged in the maritime and aviation sector. If you read German, there have actually been articles in the press very recently on this matter. The last topic I wanted to flag is trucks, because we have spent quite some efforts in the last years to look into how to boost hydrogen-powered trucks on the EU political agenda. So I just wanted to give you a concrete example of lobbying of what we did to make sure that the EU institutions would consider that hydrogen is one of the key options when it comes to decarbonizing trucks, and especially long haul trucks. So we had an event. It was the last event, I think, in a Corona time, and yeah. So this was, we had like very high level speakers. We had a letter signed by the hydrogen supply chain. Then we had a letter signed in November, putting together the supply and demand. That's the one I mentioned before. So that's also, we worked on a position paper on the infrastructure side. So here you can click and have a look at it. There was also several events at the Commissioner for Transport. Here you have different, so that's cabinets, Timmermans, head of cabinets, for example, CEOs. So that's Gerrit Marx, CEO from CNH. Well, different events. And here, just wanted to finish by giving you an idea on the cost. And that's a study. It's actually this study. You have the link there as well, on the cost competitiveness with diesel. And the idea is that hydrogen-powered trucks, at least tractor 4x2, would be cost competitive with diesel by 2027. The last thing I'm going to do, I'm going to put in the chat, is actually inviting you to join us at an event we organize next week on the logistics. So if you're interested in commercial vehicles and the logistics sides of things, we have an event, end users and well, supply and demand together, actually. So thank you for that. And now I will go to the chats perhaps and see, or or maybe you want to ask questions to me? How does it work?
Thank you for a great presentation. Now we will ask you a few questions that have been asked in the chat. First question is, what are job opportunities in hydrogen or better technologies for chemical engineering majors in Europe?
Oof, the question. I would definitely say that there are more and more job opportunities. Our members are sending us job offers, and it's not. I think there is more offers than people having the right skills at this stage. So I would say that there are opportunities. Just on a wider scale, we have just been launching a group to work on skills, and within Hydrogen Europe, as part of that's in the framework of the European Pact for Skills. And here we're exactly assessing what would be the needs, what are the trainings required or the trainings available, what are the gaps, and how can we make sure that we get the best, like we have, that people get the jobs and that the company also gets, get the right working force. And there is a similar exercise in the mobility sector with the Automotive Skills Alliance, but yeah, I could dig into that at another, more in detail afterwards, at another moment.
Thank you very much. Second question, is the electrolysis the only technology planned to be used for hydrogen production, or is there a plan to develop alternative methods such as high temperature or photocatalytic water splitting, or even bio water splitting? Also, do you plan on optimizing existing technologies to make them more eco-friendly?
Yeah, so I can actually definitely answer that part of the question. The other part, I would say, I'm sure there are. I just don't know what in the detail, because I mean it's such a fast. Yeah, I mean there are innovations on a daily basis, I would say. So I'm afraid I cannot give you the details on the what, but on the making sure that fossil-based hydrogen is more sustainable. Yeah, I mean, we are not advocating for the use of fossil fuel. Well, gray. I know we don't use colors, but well, you got my point. Combustion-based hydrogen. However, in between electrolysis, there is also what we call low carbon, and here it's basically SMR-based plus capture and carbon capture and storage, or carbon capture and utilization. And that's something that some of our members are working, are definitely working on. If you look at the, Equinor, Shell, I mean, the bigger oil players are also working on these pathways. And the Commission recognized that it cannot be renewable hydrogen only, because we need to create a market, and there is space for low carbon hydrogen as well. So this you will find it very clearly written in the strategy.
And last question, how would usage of hydrogen affect the cost of airplane tickets?
Good question. I don't know, but what is clear is that there is a growing societal pressure in the aviation segment to have a more cleaner aviation sector. So who is going to pay the bill? That's that's pretty much a question. We would need to ask the airlines there, right? But I think right now the aviation sector is what is, I mean, looking at the crisis that they are, I don't know. I would just love to tell you it's not going to be, the burden is not going to be on us citizens, but I'm not 100% sure that this is what's going to happen. So sorry.
Okay, thank you for your answers. And now Laura will announce the next presenter.
Mrs. Vesna Kučan Polak is Chief Expert Refining Research and Development at INA Group. She is a postgraduate in Faculty of Chemical Engineering and Technology, author of testing of hydrogenated vegetable oil as biocomponent in diesel fuel. The topic this presenter will address is hydrogen potentials in Croatia from INA's perspective. Polak, you may have a word.
Thank you very much. Good afternoon to all, and thank you all for being here today. Thanks to the organization of this event and the invitation to me to participate on this event also. I'm here today to talk to you about the hydrogen potential from the oil and gas company point of view. My name is Vesna Kučan Polak. I have been working in INA almost 30 years. Currently, I'm working in INA development and as a project manager for the project Hydrogen. Last 10 years, my task was focused on alternative fuels, particularly on biofuels. I was project manager for the biofuels implementation in INA. My presentation for today have three main parts. I will tell you something about our project, about the concept, where we are today and what are the next steps. But before I start with the presentation, so let me just a few words about the company. INA Group, INA Industrija Nafte, today is a medium-sized European oil company. So main stakeholders are Hungarian oil company MOL and the Republic of Croatia. You can see on the slide some figures about our activities. So we have a significant number of onshore and offshore wells and gas fields. We have 2 locations, Rijeka and Sisak, for refining of oil products and distribution. And at the moment in the region we have more than 500 petrol stations. So today we have a leading role in Croatian oil business and strong position in the regions for the oil and gas exploration, production, oil processing and distribution activities. Hydrogen. Why hydrogen in INA and where we are now with the project? So originally idea is to evaluate the hydrogen possibilities as an alternative fuel in the transportation sector in Croatia. And the main reason for that is the existing production in our Rijeka refinery. I will tell about this a little bit more on the next slide, but also to develop a new production route also. So we see a lot of benefits and opportunities. In one hand, we have opportunities for INA as a company, and other hand for the Republic of the Croatia also. We can offer hydrogen on the market at reasonable price. We can create a precondition for long-term development of hydrogen economy, and we can help our country with the contribution to decarbonization in transport, GHG emission saving, and the general transformation to green and low carbon energy using European funds. So the project concept, let's say, have 2 main parts. One is the production and another is a market. You already heard from previous presentation that with the hydrogen we still have eggs and chicken dilemma. So we also recognize this moment, because to know or to produce something is not good enough. As I mentioned, we have in Rijeka refinery steam metal reforming process technology. In fact, we have the biggest production of hydrogen in Croatia and in the region. So the steam methane reforming process is a conventional technology, and currently this technology can offer the lowest price of the hydrogen on the market. But what is the additional advantages of INA in hydrogen production at the moment? We can use also CCS technology, carbon capture technology within the company, and we also evaluate this possibility how to decrease GHG reduction of this kind of process, I mean steam methane reforming, to decrease the CO2 emission and to transfer our gray hydrogen into the blue or so-called low hydrogen. We also evaluate the possibility for the green hydrogen production via electrolysis from renewable energy sources. This is our current ongoing product. But what is with the market? When we started to work on this, we recognized, as it mentioned before, that there is no practically market for the hydrogen in Croatia. There is no infrastructure, there is no vehicles. So you also have opportunity to saw on previous presentation what is the practically the best application in the transportation sector for hydrogen. So this is a long route, heavy vehicles, where the battery electric cars are not, or let's say, don't have a good performance or are more expensive. So we see the hydrogen opportunity in especially city buses and heavy duty vehicles. And we started to evaluate this market niche. 2 years ago, in 2019, this is also mentioned by a lady before me on presentation, European Directive on the promotion of clean and energy efficient road transportation vehicles defined the minimum procurement target for the share of clean road transportation vehicles. So what does it mean in fact? This means that by 2025 in Croatia, in buses, 27% of them should be clean road vehicle. After that period, by 2030, these minimum procurement targets for the obligation companies, that is a local authorities, will be higher. It will be 37% by the 2030. So we recognize this market as a first, let's say, as a first opportunity to enter into the transportation sector and to use hydrogen as a fuel. And our vision starts to, for example, to develop this picture. You can see on the right side of the slide on this way, to establish green hydrogen production by 2025, to invest into the minimum 3 hydrogen refueling station on main transportation route through Croatia, especially on TNT networks. And by the 2030, build additionally 5 hydrogen refueling stations. And what is a learning point from our side is that development of the hydrogen should be at the same time on the production and infrastructure side as well as on the market side. With this idea, so to enter into this hydrogen application on city buses, we approached to the city of Zagreb, and they accept this concept very good, and we started our common job. And the result of that was the common concept, so-called Project Zagreb internally. So together we prepared the concept, and City of Zagreb submitted the concept of the project on the tender for funding for the technical assistance, so-called Project Development Assistance, or PDA, organized by Fuel Cell Hydrogen Joint Undertaking. It was a so hard time, and when I remember that it was almost a year ago, it was one day before the lockdown. So we are working really strange conditions that time, but as you can see, everything is possible because there were 39 applicable applications, and we are chosen within 10 of them, and we got this technical assistance. So today we are working together with the 2 consultants companies, Element Energy and Trezors, and together we elaborate the project by mid of this year. So general concept of the project is shown on the picture. So we should, as a INA, as a company, to provide hydrogen, or from Rijeka or from Sisak side, gray or green or blue. We should organize the transport, build a refueling station, and City of Zagreb, Zagreb Electric Tram, will procure minimum 20 buses. It is also important to highlight that other partners on the project, among the City of Zagreb and the Zagreb Electric Tram, we have 2 ministries on the project and 2 faculties, Ministry of Economy and Sustainable Development, Ministry of the Sea Transport and Infrastructure, as well Faculty of Electrical and Mechanical Engineering and Naval Architecture from Split. Professor Barbir is also with us, and the Faculty of Mechanical Engineering and Naval Architecture from Zagreb. Professor Kovac is also part of the project. So total estimated capex of the project is 21 million euro, and general timeline is that this year we should finish this development phase, and we hope that in 2022 we will start with the implementation. On this slide you can see a few details. INA role is to secure hydrogen, to invest into the storage and loading facilities, to organize the transport, and to build a refueling station. And city of Zagreb will procure minimum 20 buses. So the whole project probably will have finally a higher budget than we estimated on the beginning, because now we are in a detailed development. I can tell you, for example, that one hydrogen refueling station have a budget from 1.5 to 2 million euros. For example, this is a budget equal for the one petrol station at the moment. So this is only for the hydrogen. It is a huge capex compared to the existing our business. But we hope that this demo case, this demo business model will good enough to be developed with the project assistance, and will cover entire value chain and show to others, and as you know, first of that kind of business model for the building infrastructure and completely new entire value chain in Croatia. As I mentioned, so we are now in development phase, and I hope that the results of this development will be good enough, and with the European fund, we hope that implementation phase should start next year. And our estimation to finish this project is year 2025. I hope that we will have a chance to really see how this work that year. So finally, except all this activity which are undergoing now, we exploring funding options for implementation project phase. We work actively with Croatian Hydrogen Association, and we are a member of Hydrogen Clean Alliance. Also, we have a cooperation with scientific community, business partners, authorities, and of course, we constantly develop new business concept in Croatia for hydrogen application. That's all from my side. If you have a question, so I am here. Thank you very much.
Thank you for excellent presentation. There are no questions, so we'll go straight to the next speaker. The next talk will be given by the head of the sector for European funds at Ministry of Environment and Energy, Mr. Marko Markić. Mr. Markić will give a speech on EU funds and how to properly use them. You may have a word.
So please, for a start, let me thank you all for inviting me for this presentation. As I saw presentations till now, I believe you are going to be able to use this presentation as a break from all these technical things. I thought about this presentation. Actually, purpose of this presentation is to introduce to you the very concept of EU funds. So the once you'll have a chance to use EU funds, you could understand what all had to happen that some funds could be allocated and granted. As we earlier heard from Ms. Skiker presentation, hydrogen is a huge EU topic, and EU funds shall be available. And later on, you'll hear Mr. Jukić in his presentation what are Croatia's plan for how to incentivize hydrogen investments in Europe, in European Union, and actually in Croatia, and why European Union wants it, basically. I just want to say another thing about EU funds for the starters. If you could keep in mind the very concept of functioning and of European Union. European Union actually was created as project. Actually, European Union is a project. It started as an answer to a common issue for several countries, and European Union continued to be same like that all the way as a project, always solving common issue. So basically, that's the main purpose of all EU funds, to solve some common issue. And every EU fund, every European Union itself are functioning as a project, and you as engineers are well aware how projects are functioning. So basically, EU funds shouldn't be difficult to be understood by engineers. That's what I wanted to say for a start. Okay, for the second slide, keeping that in mind, what we had, what I said earlier, we should all be aware what are EU funds. EU funds are taxpayer money. They are public funds, and European taxpayers' money, all European taxpayers' money, are always spent to encourage implementation of European policies. They are always spent to achieve certain general goal of European Union, and also to equalize development of all regions in European Union, because we always have regions that are not developed in the same level as other countries, and European Union doesn't like when things are not equalized. Actually, when everybody doesn't have the same chance, basically. That's what we are trying to do. What EU funds can be used for? You probably heard for many EU funds usage, but maybe the biggest, the hugest are construction of public infrastructure. You're all aware of our famous bridge on the south of the Croatia. That's one of the purpose of European funds. It's also to unify level of development of all EU regions. Croatia, as a cohesion country, is one European region. Whole Croatia is one of the European regions that are not on the same level of development as average EU countries, and that's the reason why Croatia has probably the biggest amount of money per capita in the European Union for now. Those are our, actually, if we see our lower level of development, we have highest level of ambition. So basically, and we have highest level of potential also. You're all aware of potential energy. European funds can be used for research and development. That's quite huge for European Union. Research and development, that's something that could be very interesting to you, because it is something that wants those programs want to incentivize cooperation between scientists and entrepreneurs. Also, the main purpose probably for all EU funds is to invest in infrastructure that contributes to a certain target, and that's maybe the closest thing to your topic today. To invest in infrastructure that contribute to a certain target for next programming period, 21 to 27. Renewable energy sources, new sources of energy, new ways to save energy or to contain it is one of the big topics, and that's the infrastructure that is going to be incentivized with European funds in next programming period for certain. And that's probably why you all should be aware how EU funds are functioning, because basically you are going to need them to make your projects possible. How could EU funds be distributed? I actually put here 3 ways. All 3 are available for now. There are some more, but those 3 are basically the most common one. First one is as a grant. A grant is basically the most favorable way of giving EU money. Giving out EU money, it's the way when you invest into something, and you spend certain money, and then you request certain part of it as a refund. And investors like it a lot, because basically it makes your investment a lot cheaper. Those percentages are going from, I don't know, 40% to 80% of whole investment as non-refundable. Second way is financial instrument. There are many, of course, guarantees or incentives, incentivized interest rates, but the main purpose is to make credits, to make loans with smaller interest rate possible. And the last one is technical assistance. It's basically help, technical help to make projects work. Sometimes it's actually consultant help or help from peer-to-peer help or things like that. Okay, every system everywhere, and also system for EU funds in general has to have some kind of managing ways and managing system. We call it in EU funds managing and control system. 2 basic systems in EU funds, two main important, actually only 2 ways of managing systems are in European funds, are management of European Commission. You probably met with those kind of funds. Those are like Horizon projects or LIFE projects or Erasmus projects. Those are all those funds are managed by European Commission. And there is a second part is shared management. Shared is between European Commission and member state. I'll say more about this second one. This first one you probably know more, but and for investments, for this kind of investments, you're probably going to need shared management a lot more, especially in Croatia. Shared management is quite important for cohesion countries. Okay, as I said, I'll say more about shared management. We have, for first of all, I want to tell you about funds that are managed in shared management system. I actually listed over here just 4 of them. There are a couple of more, but for investments, those are most important, and they are with highest amount of EU funds we have in Croatia. First of them is the European Regional and Development Fund. This is the fund we could use for, as I said, equalizing of all regions in Europe. The usage of this fund is mostly in helping either companies to be more competitive, or even agriculture or other ways to help some regions to develop, basically. Second one, quite big, is cohesion fund. That fund is used to make certain reforms in countries that could make European Union coherent. You see, in every European policy, there is certain standard. Cohesion fund is used that every member state has the same standard in certain things, energy or trades or agriculture or maritime or whichever. European Social Fund is used, of course, to help all European Union citizens, especially with those low social status. That fund is I'll say more about that, but in Croatia, that is Ministry of Social Affairs is dealing with that fund. We also have that European Maritime and Fishermen's Fund that's quite huge, and Ministry of Agriculture is managing that fund in Croatia. Okay. To share funds, to distribute EU funds, we have to establish a system. Now we are establishing system for sharing EU funds for next programming period. Actually, programming period that started this year. And for first, we have to make partnership agreement with European Commission, since we are sharing management of these funds. And that partnership agreement is now in writing, basically, and in communicating with the European Commission. That's one of information, so you could have it. I believe we are going to have it quite soon. After that partnership agreement is signed, member state establishes a management and control system. On top of the managing control system is in Croatia is Ministry of Regional Development and EU funds, and Ministry of Development Ministry of Regional Development and EU funds are actually now are in charge of making partnership agreement, and all those I'll say about that more later about operating programs. Okay. So since we have one managing authority and quite widespread policies we need to make, and quite widespread of investments we'll have to make, managing authority delegates some functions and assigns part of its function to some other bodies. Those bodies are called intermediate bodies. We have level 1 intermediate bodies. Those are ministries. Ministry of Economy and Sustainable Development is a level 1 intermediate body for several, actually for I think now for eight policies. We have level 2 in intermediate bodies. Just for examples, we have a couple of agencies, and in here we have EcoFund that is intermediate body. We also have certifying authority, that's our Ministry of Finance, and we have we have to have audit authority. We have one agency called ARPA in Croatia that has audits, that does audits for all programs. After that system is established, basically intermediate bodies, managing authority, some government decisions are made, even some laws are made. Managing authorities and intermediate bodies as sectorial policies carriers are designing operational programs. That's another thing we are working on now. Operational programs are quite important. Each of operational program has to have numerical benchmarks and financial indicators for each of intervention in the operational program. Each operational program is programming, planning, and strategic document that transfers national or European strategic documents into the list of financial interventions. So if we have some European target or European strategic document that promotes hydrogen, for example. For this example, operational program has to describe how are we going to incentivize investments in hydrogen in some so that strategic target becomes available in the time frame we expecting. When operational programs are published, intermediate body only after that intermediate bodies are announcing call for project proposals, and that's when you are stepping in. Basically, when you have your projects, after that calls, I'll say that more about that later on. So this is all what has to happen just to have a call for project proposals. Some of operational programs in Croatia for next programming period. This is you could expect it, and this energy and hydrogen and renewable energy sources and are going to be part of operational program for competitiveness and cohesion 21 for 27. I told you earlier about fund for social fund, European social fund. That's one another operational program that we call it program for human resources. So after those operational programs are finalized, we'll be able to for open calls for project proposals. Let me tell you something about our favorite way to incentivize some policies, actually Croatian or national or European. Those are grant awards. Funds are to be awarded in compliance with the operational program we described it earlier. Open calls are published when there is known or unknown but many potential contributors to achievement of strategic goal. Public money is in that way is used to encourage investment that is not in itself cost effective. So basically, grant awards are given only for investments that beneficiary could not do without public money. So you have to prove that whenever you are receiving grants from public money, that project couldn't be finished without some public money invested in it. We also have other way of grant awards. Those are direct allocations. Direct allocations are applicable when for strategic projects and mostly for public infrastructure, huge public infrastructure. What is actually call for proposal? Call proposal is actually a set of documents. Those documents that are asked in for project proposals are asked to prove certain eligibilities. First of all is applicants eligibility. So if we prescribe the project call for proposal for companies, you have to prove that you are company. After that, you have to prove project eligibility. If we call for a project that are promoting usage of hydrogen, you have to prove with your project documentation that you are promoting hydrogen. You have to prove activities eligibility. So you have to prove that all activities that are planned and that are going to be incentivized with public money are in compliance with the target of your project or with the target of a call. And at the end is expenditure eligibility. Is actually you have to prove that the money you are asking for is going to be spent in compliance with project goal. After your project proposal came to intermediate bodies evaluate project proposals, and they evaluate compliance with all 4 criteria. Project approval ends up with declining or with accepting. If it's accepted, if project is approved, that you are eligible for cost refund, basically when you finalize your project or even during your project development. Key principles in the sharing actually public money. You have to be aware of that, and that is something that is always has to be seen in every project proposals, and actually in every call for project proposals. To issue public money, there has to be some kind of public interest. Public interest and compliance with goals, certain goals and targets. It has to be prevented distortion of EU internal market. I explain later why I bolded this criteria. Often, maybe some of you heard for it, state aid rules. Distortion of EU internal market. Internal market is one of the big things about European Union, and whoever does anything with EU funds knows how that is important. All EU funds, as all public money, has to be available to whoever it could come to, and everybody has to have equal access to public money. So those are the principles we have to safeguard when we are making call for project proposals, and that's something we have to check with every project proposal we receive, and whenever is some kind of project is approved. I bolded this state aid rules, and I think this is one of my last slides. I just want to tell you some more about that state aid rules, and something to be aware of. State aid rules are well-known issue. Everybody's talking about it, and rarely anyone understands it well. And basically, everything comes down to four criteria. If the project to which public funds are allocated cumulatively meets those 4 criteria, public funds cannot be awarded. It doesn't matter if they are EU funds or they are any kind of other funds. If all 4 criteria are met, public money could not be awarded to projects like that. So first of criteria, project activity is economic activity. Of course, probably any activity is economic activity. Actually, not any. Social activities are not economic activities, so basically that's why they are not state aid. Benefit that is granted is imputable to specific entrepreneurs. So basically, one of entrepreneurs or one group of entrepreneurs, you could anybody could see to whom that money went to. That's what imputable to specific entrepreneur means. State resources, actually public resources, are enabling a selective advantage to certain entrepreneur. That's not allowed, because basically you are not to public money should not make that kind of distortion in a market. And at the end, state aid causes distortion of competition. You probably, if you listened earlier, or if I explained it well earlier, there is in a regional fund there is option to give some kind of competitive to issue some money for competitiveness. But you could issue money for competitiveness only if that from regional fund, if that region is not developed on average level of development of European Union. So those state aid rules are quite complicated, and it's quite complicated to prove that something is not state aid or what kind of state aid it is. And that's why European Union came out with, in order to promote certain activities, like for example, renewable energy sources or energy efficiency, helped with certain document that's called GBER. You probably all heard of it. That's block exemption regulation. Basically, it's a list of exemptions where you have certain types of projects that you are not considering. Actually, you are considering state aid, and state aid is allowed. So basically, those projects are finding, actually those projects are meeting those conditions I mentioned earlier, but they could be exempted because of greater interest of European Union. Okay, that was my last slide. Thank you all for listening. I hope I didn't bore you too much. So if you have any questions, I'll be happy to be here to answer them.
Thank you for a great presentation. And now I will continue. There are no questions, so now we will continue.
Thank you.
Our next speaker is Head of Sector at Ministry of Economy and Sustainable Development, Dr. Vjekoslav Jukić. He's responsible for European Union policy, strategic documents, and international affairs in sector for energy policy and planning. Today's topic is what is Croatia's plan in promoting alternative fuel and energy storage, especially concerning hydrogen technologies.
So, greetings to everybody, and I'm really glad that I have this opportunity to talk today. And as I can see to the agenda, the hydrogen is really important topic regarding clean energy transition, and it really is. And I will try to give a little bit different perspective. And also I will try to present what are the plans of Croatia regarding the hydrogen. You already have a chance to see some projects, and you will see after that, because I see that also Mr. Jakić will present the fuel cell and his work. So let's start it. First of all, and I think it's important, is the question of perspective. And I will try to do this. It's on Croatian. I will try to translate. It's some icebreaker for you, and it's regarding, as I said, point of view and perception, and it's about one house. This is my house, and this is how I see it. But if I want to sell it, then the buyer will see it more like this one. And if you want to rent it, the people who want to rent it sees this house more like this one. But it's not all. If you want to sell it, or you need to some kind of grant or credit, then you need to go to the guy, the real estate guy, and he will see it like this. And finally, when you need to pay tax, the tax administration see it like this. So basically, everything is question of perspective. And my perception of hydrogen and my perspective of hydrogen starts in 2018 with this car. This is my first contact with the hydrogen cars, and when I drive it a little bit, and it was fantastic. I was thrilled with the hydrogen car. Before that, I was thrilled with Tesla and with battery car vehicles, but now they demonstrate us in the USA and in California how it can be refilled. It takes only 5 minutes or something, and it's really pleasure to drive this car. So you already heard a lot about gray, blue, and green hydrogen, and I presume that this chicken and eggs will not. It's topics that is mentioned several times before this presentation, and it is really a problem. It's chicken and egg problem regarding the setting up the hydrogen economy, not just in Croatia, in the whole world. As I mentioned, I was in California. They have also same problem. Now they are much more advanced than Croatia, but everything is same in all parts of the world. So also in Croatia. And regarding the way how we will put or build hydrogen economy, the strategic documents will help us. Here is two strategic documents. One is already published. In July 2020, EU published EU hydrogen strategy. Here is the link to the strategy. It's a small document of 24 pages, I presume, and it's sketches most important things that need to be done and till when that the hydrogen economy in EU will be boosted boosted enough to become economically viable operation. The second one is only in sketches. It's this Thursday, the government of Republic of Croatia adopted decision, and they decided that Croatia will build the Croatian hydrogen strategy, and that Croatian hydrogen strategy will be developed in the next few months. But another maybe also very important strategic documents for the EU on the EU level that I need to mention is the Integrated National Energy and Climate Plans, also developed by Ministry of Economy and Sustainable Development. That plan is something that, first of all, that the Croatia in that plan put the 3 main goals that will be achieved till 2030. First goal is regarding the CO2 emission decreasing. The second one is renewable energy, share of renewable energy in the final consumption. And the third one is the energy efficiency measures or energy efficiency target. So we need to boost the energy efficiency in all sectors. So basically, we made this document, we put our goals, and we also put 105 measures in the national energy and climate plans, and those measures need to be fulfilled to achieve these goals. And above them, there is few measures connected to the hydrogen. So as I said, next step is now to develop the Croatian hydrogen strategy. And regarding EU hydrogen strategy, you can see the 3 phases that is predicted in the strategy. First phase is from 20 to 24. It's from the last year, so that's why 2020. And they put some goals in it in that first phase. At least 6 gigawatts of electrolyzer is one of the goals. The second phase is from 25 till 30. And it's now at least 40 gigawatts of electrolyzers till 2030 built up on the in the entire EU. And the third phase, sorry, I have this. It's not 203, but 2030 till 2050. It's said that now we don't want to see any numbers regarding electrolyzers, but we need to have maturity of green hydrogen and production at all. So same as EU funds, as Marko presented before me, the financing of hydrogen projects, we have three possible ways. EU funds, or the second one is national funds, and the third one is private sector. And the best way to finance all hydrogen projects is probably to use all three, or at least two of them combined. EU funds, regarding that, that means the funds gave from the entire for the entire EU. We have a fuel cell hydrogen joint undertaking. It's also started as a project, same as EU, and the main goal for the FCHU is to boost the hydrogen economy in all EU. And they also gave some funds for the preparation of projects and for the projects in whole. And as you already have chance to see from Ms. Vesna Kučan Polak, they got from FCHU this project development assistance for this project for the city buses in Zagreb. The possibilities for hydrogen also will arise in Horizon Europe. It's something till 2020 it was Horizon 2020. Now it will be Horizon Europe, and it's for the projects that are more in research area or combining research and economically viable projects. So it's also interesting. And the third one is something new, but something old. It's called Innovation Fund. It's something that was developed under the name NER 300 before. Now it's became Innovation Fund, and it's really, really interesting. There is two parts. One is for the big projects, and second one is for the small projects, so-called small projects, till 7.5 million euros. And this is just to see regarding the Innovation Fund, what can be funded. Its first call was in the 2020, and as you can see, it's 10 billion euros to invest up to 2030. And main purpose is to avoid emission and boost competitiveness. So basically, it's completely okay with this clean energy transition and the hydrogen. And it's supporting innovation, as you can see, in energy intensive industry, in renewables, in energy storages, and carbon capture, use and storage. This is also the link where you can find more information about that. Regarding national funds, we are now, as already Marko already presented, in the programming phase of all EU funds that we have for Croatia, and it's also could be seen as national funds. So maybe most important, or most it's important topics now in the news is National Recovery and Resilience Plan. And we hope that there will be a room for hydrogen also in that in Croatian National and Recovery and Resilience Plan. But we also have here operational program 21 to 27, as Marko presented it. It will called competitiveness and cohesion, and part of the operational program, it's still on the programming, but I hope that it will be also connected to the usage and development of hydrogen economy. And the third one is also very interesting. It's Modernization Fund. It's one fund on the EU level for the 10 European countries that GDP is above EU level. So we are one of them. But regarding that, we have something about 450 million euros in the next 10 years for modernization of our energy and industry sector. basically we got the ETS sector is emission trading system sector, and we have some free emissions of CO2 that will be sold, and from that money the modernization fund and the projects regarding modernization fund from Croatia will be financed. So for Croatia we have 450 million of euros in the next 10 years, so basically about between 40 and 50 million euros per year for the projects. And the most important things that need to be financed from the modernization funds are connected to the renewable energy. It's connected to the battery and storage systems. It's also connected to the energy efficiency. So basically there is a lot of room for hydrogen also. Regarding private sector, I think that hydrogen is important for decarbonization of Europe till 2050. So basically there is a lot of room for the private sector to build their operations on the production or usage of green hydrogen. So basically it's new business opportunity. You can put it in the production of hydrogen, especially green hydrogen, but it also we will need the private sector to boost distribution of hydrogen and usage of hydrogen. So for the starts, and today I think mostly we were concentrated on the usage of hydrogen in the transport sector, but we hope in the entire EU and regarding the clean energy transition that the usage of hydrogen will be more widespread and it will be used in industry, especially in those industry that need to that use the natural gas today. It could be, you know, the natural gas could be changed with the hydrogen, with the green hydrogen, and it will decrease the CO2 emissions. So new Green Deal, I didn't mention it till now, but it's presented in the 2019, and the main goal of new Green Deal is to till 2050 that the EU became, or Europe became, first CO2 neutral continent. So basically I think that hydrogen has a great and important future in entire EU, and I hope that Croatia will also see the opportunity in that. So I couldn't remember the name of that cartoon that I looked in when I was the kid, but they also often said expect the unexpected. I think that the hydrogen has that opportunity that we can expect the unexpected. And also another line that I need to highlight is let's be unrealistic and ask for possible. That's also something that can be connected with the hydrogen and the future of hydrogen economy. So thank you. And if you have any questions, I'm at your disposal.
Thank you. We have one question for you. Why are there 0 companies working on R&D of hydrogen battery technologies in Croatia?
Sorry, could you repeat?
Yes,
I'm trying to go out from the air. Perfect, thank you. Now I'm concentrated.
Okay. Why are there 0 companies working on R&D of hydrogen battery technologies in Croatia?
Well, I'm not. It's not the 0 companies. I think that there is a few companies that working on R&D in the hydrogen and batteries. So
okay.
I cannot you know say that there is a Rimac cars, worldly famous, but also you saw in a presentation, they have R&D regarding the hydrogen. So basically we have some activities. It's not a lot, but I think it's a good start.
Okay, thank you very much.
Our next presenter is Mrs. Klara Perović. She is a research assistant at the Faculty of Chemical Engineering and Technology at the University of Zagreb. The topic of her talk is the development and application of titanium oxide-based nanocomposite photocatalytic materials for solar-driven hydrogen generation. Ms. Perović, you may have a word.
Hello to everybody. Thank you for inviting me on your student conference. And as you already said, my name is Klara Perović. I work as research assistant at the Faculty of Chemical Engineering and Technology. And today I will present you one quite, let's say, unconventional way of hydrogen production with the use of renewable solar energy. So here we will speak about hydrogen that is produced with non-carbon based sources. So just a second. First of all, for one short introduction, we all know that European Union and entire world, let's say, it's really hardly working on decreasing carbon dioxide emissions. And in order to decrease it more, we need either to improve efficiency of, let's say, today's most famous technologies that are producing energy from fossil fuels, or we need to think about some alternative ways of producing some clean energy, such hydrogen is. And hydrogen is, because of that, often being called the fuel of the future. I'm pretty much aware that today you have heard a lot about hydrogen and many good properties that hydrogen has. There are many benefits of promoting hydrogen economy, so I here won't pay too much attention on this, and I will transform on process that I'm dealing with. So the thing is that today most of the hydrogen that is commercially used is being produced from non-renewable sources. So more than 95% of hydrogen is produced from two main processes, such as steam methane reforming, that is followed by water gas shift reaction. So if we look on these two processes that are given here with two equations, we can see that we use methane as a natural gas, we use steam to get hydrogen that we called green gas, and to get carbon dioxide, which is greenhouse gas. Less than 5% of produced hydrogen is being produced with some alternative ways. Mostly we are talking about water electrolysis that is using some renewable electrical energy such as wind or solar energy, and there are several, let's say, commercially presented plans for the production of such renewable hydrogen. Here we have one figure where one scientist called John Turner in the late 90s gave several options of hydrogen production with the use of solar energy. So for me of particular interest is this last pathway that is called direct photolysis. Here we can see actually how research interest in this theme has become bigger in the years. So we can see that such way of production of hydrogen in 2004 wasn't so big, and we have less than, let's say, 100 published articles, and now in 2019 we have more than 9,000 published articles that are related on this theme. Direct photolysis of water, we can also call solar-driven hydrogen generation process. We can also call that photocatalytic water splitting. So there are different terms how we can describe this process. And in order to obtain a successful process, we need to have three things. So first of all, we need to have semiconductor material that is mostly titanium dioxide. We need to have water that we want to split and produce hydrogen from water, and we need to have the source of light. So each photocatalytic material, now I will explain you a little bit in detail how everything works, so you can maybe much easier you can understand what here is happening. So each photocatalytic material consists of valence band and conduction band. Between those two bands, we have something that we call an energy band gap. So when we light our photocatalytic material, our semiconductor material, with light energy that is equal or greater than this energy band gap, we cause the movement of electrons from valence band to conduction band. Electrons that are moving from this bottom part are leaving these positive holes. So these positive holes and electrons are called photo-generated charge carriers, and they are taking part in redox reactions that are happening on the surface of photocatalytic material. So positive holes are oxidizing water to get oxygen and proton, and proton is being reduced with produced electron in order to get final product that we want in order to get hydrogen. So not each semiconductor material can be applied in this process. This means that we cannot choose any semiconductor material and apply it here. Such material need to accomplish several criteria. So first criteria is valence and conduction band of semiconductor material need to be on certain position. So valence band of applied material needs to be more positive than the oxidation potential of water, and conduction band needs to be more negative than the reduction potential of standard hydrogen electrode. Very, very big problem that happens in such reactions is that these photo-generated charge carriers, when they are produced, they can very, very easily recombine. They can react one to each other, and more than 99% of produced charge carriers actually recombine, and less than 1% of charge carrier actually take part in these reactions that are happening on the surface of photocatalyst. So there are many, let's say, approaches today that are being conducted in order to decrease this charge recombination rate that is the biggest problem of these processes. So the biggest charge recombination happens if we want to split pure water. So here we see, if we want to split pure water, Gibbs free energy is relatively high. But if we add something to this water, such as methanol, what we can see here, we very significantly decrease Gibbs free energy needed for this process. So methanol is something that we call sacrificial agent, and those are usually different media that we add to this process in order to decrease charge recombination rate. Beside of methanol, we can also add ethanol, we can add different acids, aldehydes, and so on. But alcohols are shown, practice has shown that alcohols are most efficient in such processes. One of the materials, semiconducting materials that is mostly being applied in photocatalysis in general, not only in hydrogen generation, but also in water purification, is definitely titanium dioxide. So titanium dioxide as a material has many advantages. It is extremely stable, chemically stable, thermally stable. It is resistant to chemical breakdown, and it has many attractive mechanical properties. But where you have advantages, you also have some disadvantages. So two biggest disadvantages of titanium dioxide is very fast electron-hole pair recombination, what I already was speaking, and also very big problem is very large band gap, which is 3.1 to 3.2 electron volt. Such big energy means that this material can only be excited under UV light irradiation. We know that if we want to light our material, let's say with solar light, the biggest share of solar spectrum goes to visible light irradiation. UV light has only 3 to 5% of share in total solar spectrum. So we on some way need to improve this material, titanium dioxide, to be able to react on visible light irradiation, not only on UV light irradiation. So there are many different strategies how we can actually improve this photoactivities of titanium dioxide. Those strategies include doping with non-metals, incorporation or deposition of noble metals, but what is of particular interest to me is material engineering solution based on composite formation. This is something that we called TiO2 based heterojunction system, that we actually combine two or more semiconductor materials in order to promote charge separation, visible light response, and to achieve at the end high photocatalytic performance. So here you have the most famous, the most researched group of materials that are actually being combined with titanium dioxide. Those are carbon-based group of materials, transition metal oxides, transition metal chalcogenids, and you have multiple TiO2-based composites where you have combination of 3 or more materials together with titanium dioxide. So here you can see that in carbon-based materials, mostly you have use of graphene family nanomaterials, such as graphene oxide, reduced graphene oxide, graphitic carbon nitrides, the use of carbon nanotubes. Among transition metal oxide, you have big use of copper oxide, iron oxide, zinc oxide. In chalcogenids, you have very big use of cadmium sulfide, molybdenum disulfide, different selenides, and so on. Here you have, let's say, table with different multiple TiO2-based composites that are used for photocatalytic hydrogen generation. And really here you can see that there are numerous of combination, numerous of different materials that are being used. And also maybe what you can notice here is the very big use of noble metals. Here you have platinum, here you have gold. So the thing is that such materials like noble metals are extremely efficient in hydrogen generation. But the thing is, such material are first of all presented in limited amounts inert, and second one, they are very expensive. So if we want to look our process from some economic side, we would like to find some material that will have similar properties like these noble metals, but that will be much cheaper. Here you have, let's say, one figure which show photocatalytic mechanism that happens when we combine 3 materials. So here we have titanium dioxide, we have molybdenum disulfide, and we have cadmium sulfide. Such material we light with visible light. So if we light such composite with visible light, it means that only molybdenum disulfide and cadmium sulfide will be excited because they have appropriate band gap value. Titanium dioxide won't be excited because it only reacts on UV light emission. So here we have production of generated charge carriers, holes and electrons that I was speaking to you. And because of energetic position of conduction band of these materials, we have movement of electrons from one conduction band to another conduction band. And finally, we have movement, because this is energetically much favorable position, movement of electrons from this conduction band to conduction band of titanium dioxide, where hydrogen generation actually occurs. So this is one, let's say, look inside how on this molecular level things are functioning. So now I will give you a little bit of talk about my work objective, what I'm actually doing on my PhD, on my research, with what materials I'm combining TiO2. So my, let's say, aim, my objective of work is to develop material that will be made by coupling titanium dioxide with visible light active chalcogenids. tin disulfide and molybdenum disulfide, and also coupled with carbon-based materials, graphene oxide and reduced graphene oxide, to be applied for solar-driven photocatalytic hydrogen generation. So here I will shortly tell you why I have chosen these materials. So first of all, on my department, we have a lot of experience with working with tin disulfide, and we have used it a lot in water purification photocatalytic processes. And there we noticed that, this material has very good also reductive properties. So that's why we also want to combine it with TiO2 in processes with photocatalytic water splitting. Also, this material is very cheap. It is not toxic. It has appropriate band gap that can be excited with visible light irradiation. But his application in hydrogen generation is very, very rarely reported. Then we have molybdenum disulfide. Molybdenum disulfide, it has layered structure similar to graphene, and it provides very, very good electron transfer. Also, it has very small value of band gap. And here we have graphene oxide, reduced graphene oxide, that act as electron mediator, also co-catalyst promoting hydrogen generation. The reason why I don't talk only about graphene oxide or reduced graphene oxide is because the primary thing in my synthesis is graphene oxide that I'm using. But when I want to reduce chemically graphene oxide, I never get 100% reduced form of graphene oxide. I always have a little bit of non-reduced graphene oxide left in my suspension, and that's why I never write just reduced graphene oxide or only graphene oxide. So first, what I need to do to start this process is, of course, to prepare my catalyst. There are two different pathways of catalyst preparation that I'm currently using. First pathway is separate synthesis of binary composite that consists of titanium dioxide and tin disulfide, and titanium dioxide and molybdenum disulfide, and subsequent coupling with graphene oxide, reduced graphene oxide during process of immobilization. And second pathway consists of one-step synthesis of all these three things in one pot. So there are two types of synthesis in which I perform these two pathways. I use hydrothermal synthesis and microwave assisted synthesis. Hydrothermal synthesis is being occurred in this Teflon reactor that are being put inside of these stainless steel autoclave, and such autoclave you put in a dryer on high temperature for more than 10 hours, and after that you get suspension with your final product that you have to wash, that you have to centrifuge, dry, and finally you got your photocatalytic material in form of powder. So I am using a powder form of photocatalyst. When I finally get powder, I need somehow to immobilize my photocatalyst on a certain support to put in photocatalytic reactor where the main process is being occurred. So for immobilization, I'm using this instrument here called spin coater, where I am, with the use of certain binder, immobilize my photocatalyst on glass plate. Those are normal round plates, glass plates. After synthesis, we have characterization of the photocatalyst. So we need to know if our photocatalyst, based on characterization test, is appropriate to be used in main photocatalytic process. So here you can see the picture how main photocatalytic materials are looking, this powder photocatalyst. Titanium, of course, is white, graphene oxide RGO is gray, molybdenum disulfide black, and tin disulfide is orange color. There are different characterization techniques that are being conducted for for determination of composition, thermal stability, crystallinity, surface area, optical properties, semiconducting properties, and so on. And after this, we have the core of the process. This is hydrogen generation. So here you can see the photocatalytic reactor, what I'm using for this process. You see that the bottom of this reactor is rounded, and here at the bottom, I'm putting my glass plate with immobilized photocatalyst. It is very important for you to know that in photocatalysis, you can use photocatalytic material immobilized, like I am using on a plate, or you can also use it as a powder in suspension. So you don't need to immobilize it if you don't want, but if you don't immobilize it, then you have problems with, let's say, removal of such component from your solution. Here my reactor is having this quartz cover. The reason why here I'm using quartz glass is because I want that light that passes through my reactor also allows the pass of UV light. So here if I would have normal glass would block UV light emission. So I want also from the solar light that UV part also goes through my reactor. So also TiO2 part of the composite can be excited. This reactor is lighted with this xenon lamp, which is a solar light simulator. And here I have a pass of carrier gas that is taking my produced hydrogen from the reactor. All the samples are taken manually with gas syringe, and they are put here in this gas chromatographer that is equipped with thermal conductivity detector, and that way I can see the amount of produced hydrogen. That is everything. Thank you for your attention, and I'm open for your question. And here you have my email if you want maybe to contact me later if I maybe wasn't clear enough on some slides. Thank you.
Thank you for your excellent presentation. We have a couple of questions. Firstly, could titanium chloride work with or instead of titanium oxide? Both of which display some properties as far as an agate which is also photodegradable, but it is expensive.
Yeah, unfortunately, I don't have a personal experience with titanium chloride. I would have to see. Position of energetic bands. What I was speaking in my presentation, but titanium dioxide is most widely used because of that energetic levels that are the most favorable in hydrogen generation. So of course there are always alternatives, but the reason why we are combining always TiO2, which is the main part of our composite, is because of these energetic levels which are the best for hydrogen generation. But of course I will write titanium chloride and make a little bit research, but personally I don't have experience.
Thank you. Secondly, how efficient is the production of hydrogen with photocatalysis compared to other methods?
So if we, still this everything is on lab scale, let's say. There are only few pilot scales that are implementing this kind of method. So it's not still efficient enough for some industrial application. But what I want to say, the meaning of this process is not to use photocatalysis to split pure water. So what we want to do is to make simultaneous process that we will use photocatalysis for purification of water and also for hydrogen generation. So combination of these two processes in one reactor. So this is one, let's say, pre-test to see if this material is also good for hydrogen generation. If it is, then we will use it also in purification, water purification.
Thank you very much.
Next one is Mr. Ivica Jakić. who studied at Faculty Mechanical Engineering and Naval Architecture. He founded a company, Ajax, in Austria, that is a consultancy and advisory company for international companies for energy, steel, gas, and petrochemical companies on Southeast market. Today's topic is fuel cells. Jakić, you may have a word.
Okay, thank you very much for the invitation. I'm very glad to tell a few words about our company and especially about the association we have established in Croatia called Hydrogen Fuel Cell. It means I'm working more than 35 years energy sector in Switzerland, Austria, and Germany. And also we are following the latest technology concerning the hydrogen in this region, especially in Switzerland, which has started 4 years ago with hydrogen as the future of the energy sector. We established 2 years ago the Croatian Association for Hydrogen called Fuel Cell Croatia. And 2 days ago we had in Zagreb, one conference about usage of hydrogen in a central heating system and mixture with natural gas in order to reduce the pollution and of course the CO2 emission. But anyhow, our association Croatia has 2 main pillars. One is pillars in East Slavonian in Vukovar, and we name our program called Clean Hydrogen for Green Slavonia and Blue Danube River. And another one is in Zadar, city of Zadar, called Green Hydrogen for Blue Adriatic Sea. We want to show that production of the hydrogen in Croatia should be very important, as well as the usage of hydrogen and consumption of hydrogen. Our association in Croatia, we have more than 30 members of the PhD from University of Zagreb Mechanical Engineering, Faculty of Electricity, and also the institutes, and people are involved in hydrogen business, as well as we have a company in Croatia as Docking, which is a leader of the hydrogen production of the vehicles on the fuel cells. And the most important for us is LOHC, it means liquid hydrogen carrier, to establish the system of transport of the hydrogen and use of hydrogen in the boats and the ships we are going to develop. In Eastern Slavonia, we think that Croatia has possibility to be exporter of the green hydrogen, especially concerning the possibility to build about 1 gigawatt of the fuel cells in Croatia. It means our program in Slavonia, where we have appointed a hydrogen port in Vukovar, because the main transport of the hydrogen should be done via Danube River from Bulgaria, Romania, from the east towards the Central Europe, is Hungary, Austria, Czech Republic, Slovakia, and Germany, where the biggest consumers or consumption of the hydrogen should be. Therefore, we want to join Croatian port of Vukovar. That should be hydrogen port. It means we must have all facilities concerning the transport of the hydrogen through Vukovar. And also we want to have production of the green hydrogen in Slavonian region. As you know, situation in Croatia is like is, but therefore we think that at least 1 gigawatt should be produced of the photovoltaic fuel cells, photovoltaic power plants, and the fuel cells and hydrolyzers, which should produce hydrogen for export. Another our project is near the harbor of the Zadar. We appointed harbor of the Zadar as green harbor. It means in the backside of the Zadar, cities like Obrovac and Gračac, there are a lot of possibilities, and now there are existing there photovoltaic power plants as well as wind power plants. In the moment there is about a few hundreds of the megawatts, and our task is to switch on all these power plants instead of to deliver electricity to the grid to produce hydrogen, and this hydrogen should be used in Croatia as fuel for Croatian Navy industry and the ships and the complete transporting system at the sea in Croatia. And also we think that should be possibility for export of the hydrogen from port of Zadar with the companies in Zadar, and this hydrogen should be used in Europe as new fuel. Therefore, our efforts goes together with really I have to appreciate the efforts of the Ministry of Croatian and especially Agency for agency for protection, which have recognized hydrogen as the future of the fuel, and we got a lot of support for producing hydrogen and also to use hydrogen as a fuel. Our another pillar is to make a refit of the machines, especially tractors for agriculture industry, which are now using the diesel engine as a fuel, and to refit it on hydrogen, as well as we are trying to refit the Croatian locomotives, especially in industry, locomotives which will use hydrogen. In this point of view, we are working together also with our companies, which are member of our association in industry and shipbuilding industry, in order to produce ships on hydrogen level, to use hydrogen as a fuel. It means future of the hydrogen in Croatia, we are pushing very strong, and we have support from Croatian government, as Mr. Jukić told a few minutes ago. Croatian government has recognized the hydrogen as the fuel of the future for CO2 emission, and we are working together in this aim, 2030 and 2050, to get in Croatia. But our mostly interest is to wake up Croatian industry, speed it up to produce not only fuel cells engines, but to produce complete system towards hydrogen production and use of hydrogen as the future fuel. That's all for me for this moment. If you have any question, please don't hesitate to ask me.
Thank you, Mr. Jakić. We have no questions.
Okay, thank you very much.
Thank you.
Mrs. Nataša Vučemilović Alagić works at the Ruđer Bošković Institute as a researcher. She was the recipient of L'Oréal's scholarship for 2020 under UNESCO's program for women in science. Her research is focused on environmental preservation, and her topic for today's talk is ionic liquids in supported ionic liquid phase, SILP catalysis. Mrs. Vučemilović Alagić, you may have a word.
So thank you for the introduction. As you mentioned, my name is Nataša Vučemilović Alagić. I came from the group of computational life science at the Ruđer Bošković Institute. My mentors are Anna and David Smith, and today I will talk a bit more on the scientific side. I will talk about ionic liquids in supported ionic liquids phase, known as a SILP catalysis, and I will show why that's important in the hydrogen production. I know that it's a bit more scientific and it is mostly connected to the pure R&D. And it is my great privilege and honor to be at this conference. So let's begin. I will start with what are the ionic liquids. So when we think about salt, when we cook, we imagine small crystals because we are using sodium chloride. However, ionic liquids are also made of the positive charge cation and the negative charge anion, but those ions are bigger and they, let's say, they put some disorder into the system, and because of that, on the room temperature, they are liquids and they have a negligible vapor pressure. They also can be liquids at very wide temperature range, which is even greater than temperature intervals of water. And also, they are known as intrinsic ionic conductors because they are basically ionic plasma. They have large electrochemical windows, more than 4 volts. And also, they have high thermal stability and they are not flammable. And they can be hydrophobic or hydrophilic, which depends on their composition. The reason why we called ionic liquids designer solvents is because we can choose any cation or any anion, and basically we can tune the properties that we want. We can tune what we want in specific application. I will now show you the possibilities of ionic liquids. So ionic liquids in the applications, this is just one scheme that I found to present today. However, there is much broader application of ionic liquids, and there are also a lot of patents in the world of ionic liquids. So in this scheme, you can see 3 different applications of ionic liquids: as solvents, as electrolytes, and as functional materials. So as solvents, they are especially used in catalysis process. They are a great environment for catalysis, and the rest of my talk will be about that. In electrolytes, they show extreme potential in supercapacitors and in batteries. And as function materials, the main let's say, where they are used the most are as lubricants or as nanomaterials. But, however, the talk that the aim that we are looking is in catalysis. So I would like to emphasize that I'm a theoretician physicist, and I model this particular system. So from my point of view, I told my aim is to tell my experimental colleagues which is the best ionic liquid to use and how to tune it to get better efficiency. So this kind of system, known as a SILP system, are supported ionic liquid phase catalysis, are consistent of, as we can see, support, which is usually silica or alumina support, metal catalysis in it, mostly rhodium or ruthenium catalyst, and ionic liquids in it. And the catalyst is dissolved in ionic liquid, and ionic liquid is dispersed on this thin film as this thin film on this support. This SILP catalyst has one big advantage. It's that in this environment, as one of the speakers before said, happened this water gas shift reaction, from which we can extract hydrogen. So a water gas shift reaction is basic reaction. From carbon monoxide and water we get hydrogen and CO2. And the biggest accomplishment is for us is that we fine-tuned the ionic liquids in which this catalytic reaction has the highest efficiency. It's also used for industrial hydrogen production and as hydrogen gas purification. We, in our simulations, use a ruthenium transition metal complex, and we use that because of the low temperature at which catalysts occur is between 100 degrees and 150 degrees. So I'm a little bit fast, sorry. The left figure is showing basically our quantum mechanism that we calculated, that from this ruthenium complex we get ruthenium anion, let's say, with hydrogen being released as a product. The whole reaction is happening into the ionic liquids. What is our aim, furthermore, is to describe which ionic liquid should be used, how thick or thin ionic liquid film should be. We want to calculate properties like diffusion coefficients, how to extract better hydrogen from it. And we want to add some additives which enhance the activity by almost 30%. We did it already. We know that, for example, ionic liquids with chlor anion are the most efficient one. We know that some additive enhance the activity, and we know that film of ionic liquids is approximately 2 nanometers high. And we generally want to maximize the reaction efficiency. This is the cool part of all of that, because we are working on our computers and simulating all the things. However, our partners in Germany already has it in real industrial reactors, and this on the left side, these small white balls are basically this SILP catalyst filled with ionic liquids, and on the right side is proper industrial reactor, which give us hydrogen in the end. So this is what I want to emphasize, is that good collaboration between modeling and pure theoretical science can help experimental science to not waste many years to find optimal environment for their catalysis process or something like that. We can all together work to find the best possible system for the hydrogen production. And already we wrote together with our collaborators in Germany project to understand the fundamentals of the catalysis in such system. It has been approved by German science, I don't know how to say, academy or something like that. And too fast, sorry. The reference for today are from our last publication that includes high impact journals about mechanism of water shift gas reaction, about which additives should be used, and about proper simulations of ionic liquids in that system. If you have any questions at all or anything, please don't hesitate to contact me on my mail at Ruđer Bošković Institute. And thank you for your attention. If you have any questions, I will listen. I will listen. Yeah, it was fast.
Excellent presentation. I
can see what is the most common ionic liquids used in catalysis. So the most common use in catalysis is BIMIM. It's imidazolium ring with tail with hydrophobic tail containing 4 carbon atoms. And also the anion that we use is chlorine. The most efficient is chlorine, but we also trying with some other anions like NPF2 or something like that.
Thank you very much.
Mr. Dinko Đurđević is the last speaker at this conference. He graduated at Faculty of Chemical Engineering and Technology in field of environmental engineering. Since 2015, he works at the Energy Institute, Croatia, at the Department for Renewable Energy Sources, Energy Efficiency, and Environmental Protection. Mr. Đurđević will present us a topic titled Innovative Models to Drive Energy Security and Diversity in the Danube Region via combination of bioenergy with surplus renewable energy. Mr. Đurđević, you may have a word.
Thank you for the introduction. I hope that you can all hear me and see the presentation going on, so I don't keep you any longer on this beautiful Saturday afternoon. So again, thank you for the invitation and the presentation, and I'm happy to be included in this alumni team of the Faculty of Chemical Engineering and Technology. So I'd like to present you today, since we heard a lot about hydrogen, and a lot of speakers before me mentioned a lot of things from laboratory experiments up to potentials in Croatia, and of course the EU funding. So I'd like to let's say end it all up in a project that we are participating in, which I'm leading from the Energy Institute Croatia side, called Innovative Model to Drive Energy Security and Diversity in Danube Region via combination of bioenergy with surplus renewable energy, or shortened Danube power to gas. So just to shortly introduce the Energy Institute. We were established in '94, and in 2004 we are transformed into a non-profit scientific institution owned solely by the Republic of Croatia. Since we are government-owned, we are predicted to be on the budget, but we are not, and we have to, let's say colloquially, earn our own pays, our own salaries, and that's why we have to participate in projects to actually earn money and try to further develop the energy sector in Croatia. We have 77 employees and a lot of PhDs, since we are working a lot in the energy sector, but all other sectors such as bioeconomy, circular economy, distribution and transmission grids, and so on. And as you mentioned, here is a short presentation of our organization, but we had a slight change in the last year. So I'm coming from the Department of Renewable Energy Sources, Climate and Environment Protection, which is actually shortened since energy efficiency is another department. As I mentioned, we are working on a lot of projects, international, national, but also global. And most of our income comes from abroad projects, which we do with a lot of partners, including European Commission through European funded projects and such others. And as I mentioned, our key areas of expertise include mostly planning in the energy sector and the energy sector itself, but we also work on the renewable energy sources, environmental and climate protection, and lately, the last couple of years, we are also following trends in bioeconomy and circular economy. So that's enough about us, and I'd like to go to the Danube Power to Gas project. As Mr. Jakić mentioned, he mentioned the potential of Danube region in his presentation, and I'd like to present you why this is so important. So it's a region that encompasses 14 countries, 114 million inhabitants, and is quite large. It's going through, as I mentioned, through 14 countries, which a lot of them are in this project. And because of that, it has a great potential for development, not just in the energy sector, but a lot of other sectors. That's why there's, as it was also mentioned during one of the presentation, we have EU funds available, and one of the programs that is oriented on the Danube region is the Danube Transnational Program, which is the financing instrument of the European Territorial Cooperation, better known as Interreg. Within this program, we, let's say, as simplistic as possible, we receive grants to develop projects that would contribute to the further development and utilization of the potential that is available in the Danube region. Of course, this has to be aligned with the European Union strategy for the Danube region, which furthers the development in various sectors, and we are developing especially this project within the energy segment of the EU SDR. As I mentioned, our project is within this program, and we are working on it. It started last year in July, and we are working on it until the end of 2022. And the focus is to support the diversification of energy sources and strengthen generation and storage strategies for renewable energy in the specific area of the Danube region. We are planning to advance transnational energy planning by promoting these strategies and intensify transnational cooperation, which is one of the most important segments of the project. As I mentioned, we are financed from the European Union, and you can see our budget. Of course, it is important to mention that, as it was mentioned before, of course, we have to co-finance the project, and I won't bother you anymore with the budgeting. I'll just go ahead to the consortium. You can see that we have included 12 countries from the 14 mentioned in the region. 14 are financing partners, 10 associated partners, which will help us disseminate the results of the project. We are here included from the Croatian side, the Energy Institute, but also we are accompanied by the SDEVES, the International Center for Sustainable Development of Energy, Water, and Environmental Systems from the Faculty of Electromechanical Engineering, and our partners from the Faculty of Mechanical Engineering. So why are we focusing on the Danube region, especially in the regards of this project? We are focusing on biomass potential. This region has a huge potential for sustainable energy production in general, especially wind, solar, and biomass, but we are focusing on biomass because it's mostly unused. As you heard today, there are a lot of investments in renewable energy sources, mostly, especially in Croatia, mostly in wind and solar, and biomass is kind of put aside. But we have to follow the new strategies, especially circular economy and bioeconomy, which enable us to use the organic, industrial, municipal organic waste, agricultural byproducts, wood-based, and so on, which can contribute to the bioenergy share of renewable energy in the Danube region. And as we can see on this figure, on this slide, this potential is quite huge. Of course, this will let's say, generate a need to expand the existing cooperation between countries, so that we can use the existing transnational gas and electricity grids for energy distribution and storage. And of course, there are common problems in energy security and efficiency, which bioenergy can contribute to. As I mentioned, the bioenergy potential in the Danube region is quite vast and quite large, as you can see in these figures, especially since the Danube region is actually a region with a lot of wood, quite developed wood sector. And this is quite an opportunity to use this biomass and unused biomass to develop the bioenergy concept. Of course, we have to follow global trends, and that is why we wanted to couple various sectors. What is sector coupling? Just to start with, so I can introduce it to. It is the interconnection of energy-consuming sectors, especially heating and cooling, buildings, transport, and industry, with power-producing sector. This is a holistic approach, which will enable us one day to remove techno-economic policy and regulatory barriers, so we can use renewable energy sources in each segment of the economy and help contribute to the decarbonization of economy. As I mentioned here in the following bullet, it can assist us in the decarbonization of national economies. And of course, contribute to the final goal of the European Green Deal and other strategies, and which is achieving net zero emissions. So here is the concept of our project, and I just received the other day a deliverable, which my colleagues from Austria explained the project perfectly, and I would like to read it to you so you can follow it on the figure. So the project idea of Danube Power to Gas is to process unused organic residues to biochar for an easy transport along the Danube River, which is actually this part here on the left, and use it as a basis for synthesis gas, actually syngas generation, which is here a part with the conversion. We will use this syngas to upgrade it to renewable natural gas by adding hydrogen produced from surplus renewable energy, which is this part in the upper part with fluctuating renewables, especially solar and wind, which I mentioned, which are quite generous in European Union area. And this enables storage of energy in the existing gas distribution grid, which means that we will use this syngas for utilization in the natural gas grid. So we are coupling electricity generation sector with the natural gas grid through production of hydrogen and using it to produce syngas. So we are actually using hydrogen and syngas as storage for the renewable electricity that is generated in the fluctuating renewables such as solar, which if you don't have sun, you don't have energy, and wind, if the wind doesn't blow, you don't have the energy generation. Here is a simplistic overview if you want to see it like that, but this is the basic concept of the project. The objectives of the project are building a trans-sectoral energy community, the sector coupling as I mentioned before, developing instruments for the coupling of gas and electricity sector. So we are building various tools that will help the coupling, and guiding the way to new energy storage investments, which I will present to you afterwards. We will, with this in mind, we will contribute and advance diversification of renewables, especially implementation of the biomass and biogas concepts and segments of the renewable energy sector. Improve the energy efficiency through utilization of unused surplus electricity, which is generated in wind and solar energy. Integrate different energy grids. This is the part with coupled sectoring. Sector coupling, improve the framework for sector coupling through transnational strategies and national roadmaps for energy storage, and increase knowledge transfer and transnational cooperation. Of course, this is all within the concept of sustainability, which means that we have to use the biomass that is sustainable and not use the biomass that is predicted for some other use, for example, food production. And of course, all in all, generation of renewable energy, which includes wind energy, solar energy, biomass, biogas, and so on. So the final goal of the whole project is to support the development towards sustainable renewable energy and job creation in rural areas via local bioenergy production and storage in the Danube region. This we will do through main activities and main outputs. As maybe some of you know, international and transnational programs, especially EU-funded programs, are conducted and implemented through work packages. So within this project, we have 6 work packages. Of course, 2 are standardized, such as management and communication, but 4 are technical. The first work package is the generation of Danube Energy Platform and Transnational Renewable Energy Atlas. So the idea behind the Danube Energy Platform is to bring together stakeholders of the energy sector in the Danube region and increase the cooperation between them. We are focusing and basing this platform on the concept that was developed in the Energy Barge project that was predecessor of this project. And we want to develop a renewable energy atlas within it that will present the availability of biomass, amounts, prices, and logistics, and through that enable the stakeholders and users to see where the available biomass is in the Danube region so they can use it. And of course, within this work package, we will do the trainings of the developed, on the developed atlas. In the second work package, we will do the assessment of infrastructure and biomass in the Danube region for each country itself and the pre-feasibility study. What does that mean? That means that we will do an analysis on the biomass potential and infrastructure, pinpointing on the map on the energy atlas where biomass is available and which infrastructure is available at which location. Especially regarding infrastructure, this will include renewable energy plants, access points, transport hubs, transnational links, and so on. And regarding the economic feasibility of local sector coupling, we will do a study which will include simulations by segmented regions, assessment of regions themselves, and so on. This will enable us to create a tool for optimizing sector coupling hubs, which will be points and specific location for the investors, which they can create their let's say electrolyzers or biomass hubs or something like that, where they have the necessary the necessary requirements for their future work. Meaning they have the biomass, they have the necessary infrastructure, and they have the specific economy, which will enable them to make a profit and provide the market with the needs, the syngas or the hydrogen. The second work package is related to the policy and legal framework, which is of course important since the topic, as we heard today, is quite new and the regulatory framework is not yet developed. And within this framework, we will do a policy and strategy assessment and strategy development. And of course, communicate with relevant decision makers and stakeholders to improve and try to increase the input and implementation of hydrogen in the creation and of course the regional strategies and policies. And of course, the last working package is related to future projects and funding, within which we will develop a subsidies catalog where investors can see which subsidies and incentives they can receive from the government and on the national and regional levels. And of course, workshops for future projects and funding, where we will try to network all the stakeholders on national and regional level so they can try to create new projects and further implement and increase and improve the development of hydrogen in the national, regional, and of course global economies. So that's from my side. I hope that I rushed through the presentation and through the project, but of course you can follow us on the website of the project, Facebook and Twitter, for the news which we will have during the project and the work we will do over the project. And I hope that by next time this year we will, by the next year at this time we will have some deliverables, and I hope that I will be able to present it to you. If not, that you can follow us on these pages. So if you have any questions, I am open for them.
Thank you, Mr. Đurđević. We have one question for you. What exactly is considered unused biomass in Croatia, and is it going to encourage deforestation?
That's an interesting question, and to start with the second part, it will not encourage deforestation because we plan to use the biomass that will be sustainably developed. So we have to follow the sustainability in the whole concept and try to use the biomass that is unused. So I'm getting to the first part of the question. Unused biomass would be, let's say, waste biomass from municipal sources, or let's say, waste biomass from agriculture or forestry sector, which is actually unused. It is not ending in the landfills, but it is used for other purposes. So we are not using, I'm putting the quotation marks here, we are not using the biomass that is natural. We are not encouraging new sources, but the biomass that is waste biomass, let's call it like that, secondary biomass.
Okay, thank you for your answer and great presentation.
Thank you.
So we would like to thank all participants for listening and all presenters for excellent presentations. The recording of the whole conference will be published on Student Section YouTube channel later on. I'm certain that this conference will be the first of many to include Croatian progress in transition of clean energy. Thank you all for coming and sharing your knowledge. We wish you all a nice day and hope to see you on some of our next projects. Goodbye all.